Okay, we are live now. Welcome, everyone. Shyam, do you want to introduce and start the proceedings for the day?
Yeah, thank you everybody who has joined for this blockchain masterclass. We will start the session now, and we'll have CSRK Prasad to introduce and start the session, uh, and we'll begin our session immediately after that with a welcome address. CSRK, over to you.
Good morning to Professor Raman Rao, our director, and also my friends Radheshyam, Dr. Vidy, Gopal, and then one more Sai Charan for joining this wonderful morning to conduct the 4 hours webinar session on the blockchain technologies. So we're happy that we had a collaboration and MOU with the NatSaft to bring in the blockchain technologies to the campus and also to educate and also train our mainly students. So as a first step, probably Shyam took the initiative to share these applications of the blockchain technologies to among the faculty members. And then these faculty members will act as a mentors to our student community. I think under the leadership of Professor N.V. Raman Rao, we are having a collaborations with leading startups like NatSaft. We are looking forward much more and effective interactions with the NatSaft. I hope in the long run, both of us will get benefited. So with these few words, I request our beloved director, Professor Raman Rao sir, to address the participants.
Very good morning. At the outset, let me extend a warm welcome to all the panelists and the participants. Professor CSRK Prasad, Advisor Corporate Relation at NIT Warangal. Shri Shyam Mamadi, Director of NatSaft Corporation. Shri Gopal Bang, Business Development Manager, Blockchain R&D Lab, Curtin University. Dr. Vidy Potdar, Associate Professor, Director of Blockchain R&D Lab, Curtin University. And Sai Charan Mamadi, who is the Blockchain Solution Architect, NatSaft Corporation. Today we have joined here to conduct a webinar on blockchain masterclass. So this is a crucial time for education sector, and we are passing through the most difficult times in these unprecedented times and disruptions induced by the COVID pandemic. The future is uncertain. However, institutes like NIT Warangal should plan the way forward for other institutes and show them it will be the responsibility of institutes like us to facilitate continuous and uninterrupted learning to students. And that is where we have to do collective sharing of resources. I'm glad that NatSaft Corporation, which is headed by one of our distinct alumni, has come forward to conduct this webinar on blockchain masterclass technologies. In fact, NIT Warangal and NatSaft Corporation, Singapore have signed an MOU during our Institute Diamond Jubilee celebrations last year for setting up and running a blockchain innovation center at the Institute. I'm happy to share with you all that Shri Shyam Mamadi, Director NatSaft, is our proud alumni, passed out in the year 1986. So today NatSaft has done a day's session for participants at Technosian, a national level student technical event at NIT Warangal. It was very well received, and NatSaft is in the process of setting up and running the BIC programs. Launching a blockchain innovation center is going to be an important milestone in our institute. Probably it will take place shortly after this COVID-19 crisis, or even we can do it online depending on how things turn out, shape up. In fact, I would thank Sri Shyam, who came forward to conduct a 4 hours session online with the faculty of NITW to introduce blockchain and its applicability to the education industry. This session will help the faculty to understand how blockchain is impacting various industries, namely government, financial, manufacturing, supply chain, healthcare, agriculture, and farming industry. So after successful completion of this webinar, our participating faculty member will act as master trainers, mentors, along with the engineers from NATSAF to impart this technology to our students at the proposed Blockchain Innovation Center. Today, the mantra is in this knowledge era, research and innovation are the key aspects of education and development. So, utmost priority must be given to facilitate and support for uninterrupted continuation of these processes under all circumstances. And this is one more step in that direction. So, we have to learn and grow right from the safety of our homes to the rapid pace of technological changes. I mean, it has undoubtedly transformed the future of jobs in India, and it is our mission as an institute to empower students towards futuristic technology like blockchain, artificial intelligence, data science, cloud computing, cybersecurity, and IoT through technology. And this is one of the first in the series. So I once again thank the organizers and congratulate them for their successful, and I hope and wish that they'll conduct many more such webinars for the benefit of faculty and students in general. Thank you very much. Thank you all.
Can I have the slides and put up the agenda first?
Okay.
Thank you, Dr. Ramana Rao Garu. Your initiatives and the way you have led the university to collaborate externally with the other industries has been phenomenal, and I think everybody at the alumni have recognized the efforts you have put. And yesterday, NIT Warangal has signed a smart grid initiative and a MOU with ABB. So this is continuing even among COVID times. The activities are going on under your leadership. So thank you very much for that. And we hope to see continuously more and more industry collaborations happening. And as alumni, we are indebted always to the college, and we will give back in whichever ways we can. So, welcome all, and we will begin our session. It's a long session, 4 hours, so it will be very difficult to find yourselves concentrating on the speakers and these sessions. But I will try to make it as interactive and keep you engaged. Use the chat buttons to pose your questions at any point of time, and then you can also give us a signal of whether we are doing well. That'll boost us in whatever we are doing. And saying to all of you, take your logical breaks as you want, and we will try to have more interactive sessions. So your questions, if you pose, we will allow the speakers to respond to them at logical breaks. We will get to know your questions, and then we'll pick them up, and then we will respond to them. Today's topics, we had the introduction and objective setting by our director, N.V. Ramana Rao Garu, and CSRK Prasad. And I will now go through our speakers itself and presenters today. Dr. Vidy Potdar, Dr. Vidya Sagar Potdar, actually, is at Curtin University. He is the director of our blockchain R&D lab, which NatSoft and Curtin University run together. And so welcome, Vidy, and your insights of basically how we initiated the blockchain initiatives together, and what you have done in order to gain that momentum at the lab. And you can also share what we have been doing at the lab, so that that will be a very good way of showing the others too. And Gopal Bang is the business development manager and the blockchain R&D center manager from NatSoft. Sai Charan is the solutions architect, and he has been responsible for bulk of the work we have done from a technology perspective and for bringing all the solutions together. So welcome everybody. Thank you for being here. And we will go on to the agenda to see what we will be covering today before I hand it over to Vidy. We will start this session with a slight introduction of blockchain R&D lab, which we have set up at Curtin University, and you will get to know how we have evolved in the last 6-7 months of journey, and what are the key initiatives we are doing, both from a research perspective and from a development perspective. And you will get to hear from Dr. Vidy on the evolution of the blockchain and the fundamentals there. Thereafter, I will step in again to show how blockchain has been transforming the industry. And as much as possible, I'll try to be generic. I have seen among the participants, bulk of the people have rated themselves about 2.2 is the average among the 5. So we will not go very technical today. We will do the technical sessions later or in much more detailed courses. Today we'll try to be little more generic, but we'll give you an idea of how the transformation is happening today, what was before and what is now. And then finally we will have Gopal and Sai to take us through the use cases, and you would be able to see on the possibility of the time though 3-4 demos on what really we have done and what is really happening in the industry. Okay, and then we will have Q&A session. We don't know whether we'll end at 12:30, but we'll try to keep to our time frames. With this, Dr. Vidy, over to you for a great start.
Okay, thank you, Shyam, for this fantastic introduction, and welcome all the participants from NIT Warangal. It's a pleasure to speak to you all remotely, being here. What a technology! I sometimes feel it is we are in a very exciting time where we have access to such fantastic technology that can kind of disappear all the boundaries, physical boundaries that we have to make something happen. So I can see 44 people online now. That's fantastic. So what I'm going to do today is I'll give you a bit of a background about the blockchain R&D lab that we have jointly set up at Curtin. And then take you through a kind of a primer of what is blockchain, what is blockchain technology, like Shyam said, we'll try to keep it non-technical on this session, but in the future sessions we may run more core technical sessions on this. So let me get my slides in order. So give me 1 sec to till I organize that. Okay, so let me start off with an introduction to Blockchain Research and Development Lab at Curtin University. We are based in the School of Management in the Faculty of Business and Law, and I'm an associate professor there and also the director of Blockchain R&D Lab. For those who are not very aware of Curtin University, I thought I'll spend a couple of slides to give you a background of our university. So this is some of the pictures of Curtin's campus and the upcoming or the newly launched medical school building in Curtin. So Curtin is based in Perth in Western Australia. So we are kind of very close to India. We are only 2.5 hours ahead in terms of time zone. And we are aligned with the same time zone as in the rest of Asia. So Singapore, Malaysia, China, all we are in the same time zone as these countries. Curtin is a research-intensive university, so we do pride ourselves in the research that we do and the kind of technology that we develop. We are also ranked in the top 1% worldwide in the universities. We're also 21st in the world for universities which are under 50 years old. So that's a bit about Curtin and our background. So now about the blockchain research lab, we kind of started working discussions with NatSoft in 2019. That's when we formally launched the lab in partnership with NatSoft. NatSoft definitely brings in excellent skill sets in not only in blockchain, but a wide range of other emerging technology areas, including IoT, machine learning, AI, and so on. Over our journey with NatSoft in this time frame, we have done a number of interesting projects. I'll briefly talk about them in this presentation, but our focus has been on supply chain areas. We have done some really great work in that space. Okay, so before I go to the next slide, just to lay a bit of a context. So what we have done, Curtin has actually made up a very interesting video that shows the capabilities of the blockchain research lab. So I'll play that for you to have a feel. And also one of our colleagues from NatSoft, Srini, is also speaking in this video. So I'll play that and then we will continue with this presentation.
Blockchain is a disruptive technology that has taken us by storm. We have seen cryptocurrencies like Bitcoin come and change the entire finance industry. We are now seeing blockchain, how it transforms and disrupts other businesses and different sectors within our economy. Blockchain technology offers trust between transacting parties like businesses. It also helps you to secure and safeguard your data, business data, such that it cannot be tampered with. It also offers end-to-end visibility and traceability in business transactions. We understand that there is a lot of demand for emerging and upcoming technologies like blockchain in the industry and government, which is why we have launched the Curtin's Blockchain R&D Lab.
NatSoft is excited to collaborate with Curtin University and industry partners to make Blockchain Research and Development Lab as an innovation hub for solving real-world industry problems using blockchain and other disruptive technologies.
All businesses are different, so there is no one-size-fits-all kind of a solution. So we need to work with our collaborators, with our project partners, to understand their problems in detail, in depth, and carve a solution that fits perfectly to their problems. This is how the lab distinguishes itself, because we provide complete end-to-end solution for our partners.
Blockchain Research Lab, a place to go for research, education, development, and implementation of blockchain solutions.
If you think blockchain technology can help you or your industry, send us an email and let's begin the conversation.
All right, so that was a brief introduction to the lab, and basically tells us what is it that we try to achieve, what are our objectives behind setting up the lab. And it is pretty clear that what we want is applied research, demand-driven research, where we are working with our industry partners closely to build solutions that change, bring a real-world change. Over the past year, we have done a number of events. You can see some of these photos on this slide. But we have been actively running different types of workshops and networking events where we are getting people from different industries to come. We ran sessions on blockchain for agriculture, blockchain for education, and many other topics like that. Getting onto the team who is behind this whole initiative. So like I said, I'm the director of this lab, but we also have the mentorship of Professor Fran Ackerman, who is John Curtin Distinguished Professor of Management, brings in a lot of experience from project management, really handling large multi-party projects, and also Professor Julia Richardson, who is our head of School of Management and also a careers researcher. So it's a good team that we have here. We also have a governance team, which includes people from our research department, our Dean of Research, our colleagues from NatSoft, and so on. So we work quite closely within the university, and also our partnerships with Research Office and also NatSoft. These are some of our research students who are currently pursuing their master's or PhD degree in the space of blockchain. So that is exclusively, these are not all, these are only those who are working on blockchain. And you can see their research topics under their name. All right, moving on to what kind of research we do. So these are some of the research areas that we are currently working on in the blockchain space. So blockchain interoperability is one area where one of my PhD students is working on. And I think this is a very important and a relevant topic, given the fact that as we see, there are many different blockchain platforms in the market. It would be necessary to have a technology or a platform that connects different blockchains together. So we are very actively researching in that space. Blockchain adoption is another area where one of my other student is working on, and the idea here is to work with the industry to understand what is it that is preventing them or limiting them from adopting blockchain. So that's a very interesting project that we're doing. Like I said earlier, we are doing a lot of work on supply chain and blockchain, and I'll briefly show you some of the projects that we are currently working on with NatSoft. And then there are various other areas, specifically where blockchain is an integral part of the technology suite. So I like to remind people that blockchain is not the solution to everything, and it is not a standalone technology. It is it works in collaboration, or it works together with different technologies. So you can see earlier I mentioned we worked on AI, machine learning, IoT. So these all technologies come together to make a complete solution, and we are working on those technologies with as our research areas. We're also looking at identity and self-sovereign identity on blockchain, because that is what we see as one of the future trends where blockchain can make a real big impact. And another area where there's quite a bit of potential is in the space of marketing and blockchain. There are a lot of opportunities in that space, and it is still a very underexplored area. Some of the projects that we have done or we are doing now, it's just a brief snapshot of where blockchain we have used blockchain. So we have used blockchain for traceability of oranges. This was one of our industry requirement that came through. We also built a solution for traceability of flax seeds using blockchain, and we are currently even working on it at the moment as we speak. We're also working on medicinal cannabis and hemp traceability, mining and mineral traceability for because if you are aware, WA or Western Australia is one of the major markets here is mining. So we have a solution for that built on Hyperledger platform. Another one is on warranty management, and I guess Gopal and Sai are going to talk about these projects in further detail later on in the session. So I will not spend too much time here. We've done some work on audit and compliance with blockchain, land registries with blockchain, energy management, securing cryptocurrency. So what I want to say is we have done a fair bit of work in this area in a very short span of time, and the amount of interest that we have gathered from industry as well as from students is enormous. So this, you can see, one of the events that we ran last year. This seems thing of a past now. We no longer have physical meetings lately, but yeah, so this is what we have been doing. We've done a lot of research articles. Some of them are in progress. Some we have already completed and published. The lab has been quite active in building the Australian National Blockchain Roadmap. So I was quite actively involved in that space as well. So yeah, so that's a brief snapshot of what we do as in the blockchain research space at Curtin. So I will now, if you have any questions about this, please do post them in the chat window. We will take them at the right time. I'll now move on to my second presentation, where I'll be talking about blockchain, about the technology itself. So give me a sec till I swap the slides. All right. So in today's session, I'm going to talk about in the first part, which is on evolution and fundamentals of blockchain. So what I would like to do is to give you a flavor of this technology, what it is, what are the core concepts that are underlying blockchain. And it will open up the opportunities for you to think about how and where this technology can be applied. You know, there is a lot of potential with this technology if it is applied in the right context and in the right fashion. So I'll begin that now. So first and foremost, the question that comes is, what is blockchain? You know, there are a lot of different ways in which you could explain what a blockchain is, and sometimes you understand that, and sometimes it creates more confusion of what it is. So what I want to do is explain to it in a very simple way, so that at least you remember that. You know, so if I have to explain someone what is blockchain, I'd start to relate it with a database. Okay, so I'll tell you, everyone knows a database. You have used a database. So let me explain you how blockchain is related to a database. Okay. So in simple words, I would say blockchain is a database. Okay, blockchain equals to database. Just keep that, remember that, put that in your brain right now. Okay, one thing if you remember out of this whole 4-hour session is blockchain equals a database. But if blockchain was equal to a database, then why do we need a, you know, that becomes a very interesting question. So to answer that, blockchain is a database, but it is a little bit different kind of a database. You know, and that difference in the database makes it a blockchain, makes it unique, makes it valuable, and which is why it has created such a hype all around the world. Okay, what is that difference? The difference is, in a blockchain type of a database, you can add information like you do with any traditional, any existing database, but you cannot delete it. That is one key feature of blockchain that makes it a blockchain. Yeah, you can add information, but you cannot delete it. So keep that in mind. That is the difference of blockchain. There are a few other features that I will talk about in the context of blockchain, but that is one fundamental difference. And a lot of applications or the use cases where blockchain is used or is being explored to be used relies on that feature, because that gives us trust. It gives us the ability to believe the information that is there in the database. Nobody can go and change the information once it is added to a blockchain. So that is one core idea, core feature of blockchain. That is, information cannot be changed. So a number of times when I say this, one of the questions that people ask me is, what happens if I enter something wrong? It could be a human error. I typed something wrong. I typed my email address wrong, or whatever information I want to type in, add in. I made a mistake, an honest mistake. Can I go back and change? And the answer is no, you cannot. The only thing that you could probably do is go back and add the information again correctly and make a reference that the information that I added previously was incorrect, and give some justification. This is what it was wrong, or I made a mistake doing a data entry, or something of that sort. So what that is giving us is visibility and transparency of information that is available. I can trust that information that is recorded on the blockchain will remain there irrespective of any attempts to tamper it. Tampering will not be possible. Okay, so keep that one thing, that idea in mind. I see one question from Dhanikonda Shiva Sharma. Can you throw some light on your research on blockchain applications in smart grid area? I will definitely do that. We'll take that question in the Q&A session. But there's some really exciting work that we are doing in the smart grid space. I will definitely cover that. Okay, let's talk a little bit about the evolution of blockchain. Where did it all start? When did it all start? And why has it suddenly become so popular? So the core technology that's used in blockchain is not new. It has been around. The basic technology is cryptography, encryption, digital signatures. These technologies existed in the past, many years. What has happened is, the way these different technologies are put together and the way they operate under the umbrella of blockchain, that has made it very special. Whenever you're using, say, internet banking, you're using cryptography. You're using the core security technology. So the same thing we are using in blockchain as well. But if you think about internet banking or mobile online banking, it has been around for many years, but blockchain is relatively new. Why is it new? Because somebody thought about a different way in which you could use the same technology combination. So that is introduction. So one of the first applications, or the invention of blockchain for that matter, was in 2009, when someone with their name Satoshi Nakamoto launched Bitcoin. So you all might know what a Bitcoin is now, but what is interesting is nobody knows who Satoshi Nakamoto is. Somebody who has created a multi-billion-dollar or even maybe trillion-dollar platform. We don't know who that person is, or whether it is just one person, or is it a group, or is it friends, or is it a community? Nobody knows that. And if you think about it, in this digital world, if you cannot kind of find out who the founder of such a big platform is, it is very interesting to know. It's very interesting to think about it. But yeah, so that's what happened in 2009 when Bitcoin was launched. Bitcoin was an example of a application of blockchain. And then things started to progress. People in the tech space realized the value of this technology. Some innovations came in. So initially, Bitcoin was purely transacting on value, financial value, which was Bitcoins or smaller parts of Bitcoins, which is called Satoshis. At the moment, I don't know, I haven't seen the Bitcoin price, but it went up as high as $25,000 for one Bitcoin. And if you had that much money, you could buy one Bitcoin. But if you didn't have that much money, you had to buy Satoshis, which is like a smaller part of a Bitcoin, not the full Bitcoin. Okay, so that started and then in 2011, 2012, we started to see a lot of interest. Ideas such as smart contracts came in. So what is a smart contract? A smart contract is a way of kind of automating some business activities or processes or business processes, so that things can happen in parallel, simultaneously. It will save time and improve productivity. So, things like those came. Ethereum was launched with that feature of smart contracts, and so on. So we are still in early days of this technology, and people are still trialing or testing to see whether they think this is the right technology or not. There is a lot of how to say curiosity among people on this exciting technology. What are the possibilities, what they can do. And at the same time, the technology and the platforms itself are progressing as well. So some of them are mature, some of them are still getting there. So it's a very exciting and interesting place to be for you all as students right now. And it's great to see that you are all of you are attending this webinar to see this, your interest in being part of this. Okay, so if you look at the generations of blockchain, so what has happened? So initially, like I said, it started off as Bitcoin or as a digital currency. People saw the value in that, and then the concept of smart contracts came in. So I consider that as the second generation of blockchain. And then we are now moving to a third generation, where we are thinking about all the different applications that are possible using blockchain. So yeah, so that's those are the three areas, I think I would say, the generations of things. I just noticed comment from Shankar Banaut. It's a very informative session. Thank you, Shankar. I really appreciate that you're enjoying this session. All right, so let's look at some of the features, blockchain features, what they have. So I have listed 6 core features here. One is transaction verification, transfer of value, immutability, security, smart contracts, and distributed consensus. So when you imagine blockchain, what we are thinking about, or what we are really talking about, is transactions and the validity and authenticity of these transactions. Okay, so, and why is that important? It's very important for businesses. If I can, with 100% confidence, say that this transaction happened, the information that is there in this transaction is correct and it is genuine, that is very valuable, for companies or for their business partners who are going to use this information. All businesses are transaction. You can imagine businesses are mostly transaction based. I order something, somebody places supplies me with my request. Everything is transaction oriented, and if that information is verified and it is available for use, it can automate a lot of business processes. Okay, so the next point is transfer of value between peers. So why do we want all or multiple participants to come and be part of the blockchain network? Because the value is in collaboration. The value is in the network of people being together. The third feature is immutability, and I touched upon this a bit earlier as well, where I said information on the blockchain is immutable. You cannot go back and change what has been what is added there. So the benefit of that is it makes the platform very secure. You can rely on the information that is there. Blockchain also offers the ability to host and execute smart contracts. And what is a smart contract? In a simple way, you can consider it as a if-else kind of a logic. If something happens, do something. Okay. So an example could be, if I received my order, which I ordered online, give a 5-star rating to the supplier from whom I bought it. So this is an example of automation. It could also be that if I placed an order to my supplier to buy something, the moment the supplier ships the order, make the payment, or the moment I receive the order at my premises, I authorize the blockchain platform, and it issues the payment right away. So you can see the way in which we can kind of automate a lot of business processes using this. And the last element here is blockchain distributed consensus. So it is a very technical concept here to kind of introduce you at this moment, but to explain it in a simple way, what blockchain is blockchain is a distributed or a decentralized network. A copy of blockchain can be placed on hundreds or thousands of machines all around the world. On one end, it makes it a very secure information storage, and on the other end, we need to ensure that the information that is stored across this entire network is consistent, and everyone agrees on that information that is recorded there. So which is why we need a consensus on the information that is there on the blockchain. So that is the concept of distributed consensus. What are some of the benefits of blockchain? It is cryptographically secure. So it is using a technology, it is using technology which is proven. Encryption, decryption, cryptography, digital signatures, it's all proven, it's all used in the current business environment. Records that are added to the blockchain are tamper-proof. You cannot go back and change information, which is very important for a lot of businesses, which is what results in the trustworthiness of the entire platform, because I can trust the information that is there because I know nobody can go and change it. It also improves business productivity, because a lot of processes, like I mentioned, using smart contracts can be automated. So that improves the transactions. It reduces the cost because the human element is reduced. A lot of things can be automated or programmed, which gives the efficiency processes, operations. Provides complete transparency. You can go, if you have the access to go onto the blockchain, it will be it will be visible to everyone. There is no central controlling authority, and there is no single point of failure. So these are some of the benefits. Some of these benefits apply to public blockchains, and some apply to a private blockchain. So there is a difference between two different types of blockchains as well. I will cover that shortly. So in an example, from a process perspective, if you think about how blockchain works, so this is a very good figure from Block Geeks that shows how blockchain operates. So the first step at the very top left, you can see here, is someone sends a transaction. So when you think about blockchain, think about it from a transactions perspective. So everyone is transacting with each other in some shape or form. So a transaction is created or is initiated. The transaction then is broadcasted to the blockchain network. Yeah, because we have to verify the transaction, the content of the transaction, or the action that the transaction is going to initiate. The next step is, so that's this step here. So distributed, like I said, multiple networks, multiple nodes. This then goes on to verification or validation, where the content of the transaction or the activity or the process initiated by the transaction is validated by a group of validators, you can say, or somebody who is there to validate the content or the transaction. Once it is verified, that information gets added to a blockchain, or that information is in a block that gets added to a blockchain. Okay, so one thing I did not cover till this point, and I realized when I saw this, is what is a block in a blockchain? That is one of the very important questions. People might be wondering, I'm talking about blockchain, but I haven't talked about what is a block and what is the chain. So let me explain that at this point. So a block is a collection of information. Yeah, you can consider it as data, or you can consider it as a list of transactions. Okay, so a block can be, for those computer science background students, a blockchain can be considered as a data structure. Yeah, so we had linked lists or arrays in which we store data. Blockchain is another type of a data structure. You can if you want an analogy of what I'm talking about. So information in the block can be plain textual information, whatever we want to write. My name is, I'm going to talk about today, any textual information, or it could be information such as transactions. I transferred X amount of money to Y person. So that kind of information. So that is what goes into a block. Yeah. What is the size of the block? So that is another question that comes up. And the size is something that can vary from a blockchain platform to platform. Yeah, so it could be 1 MB, could be 2 MB, could be 10 MB, and so on. But a size is something that we can fix, that we can decide when we are setting up a blockchain ourselves. Okay, so block has a data inside, and so once the size of the block reaches, say, 1 MB, we can create a new block. All right, but we need to connect these two blocks somehow. So we know that this is a block 1 and this is block 2. So what is it that we can do to make that connection? Yeah, and that connection, to make that connection, we use a concept from cryptography called as hashing. Yes, I'm not going to what a hashing means, but in simple words, a hash is a fixed length text or a code that is generated by taking all the inputs from the block. So you imagine a block with all the information that I mentioned. You put it in this black box, which is the hashing function or algorithm, and out comes one text, one alphanumeric string, that is a hash. And the beauty of hash is, hash will not change if you provide the same data to the hashing function. So if I have the same data, goes into the black box, gives me the same output. Yep. However, if there is even a tiniest change to the content, yeah, so in the block I add 1 comma or a full stop or any other character, even 1 character difference, I put that in the hashing function, the outcome will be completely different. Okay, so that is why hashing is required, to prove that nothing has changed in the block. And the hash of the block 1, we copy it into the into the block 2. So that's how we chain 2 blocks. So that's why it is called a block and a chain. So blockchain. Okay. this is an example of the same thing what I explained. So I'll skip on this. All right. So there are two types of blockchains, or there are three, but I'll just explain two here. One is a private blockchain and one is a public blockchain. So Bitcoin or Ethereum is an example of a public blockchain. And what does it mean by a public blockchain? A public blockchain is open for anyone to join. Yeah, any member, anyone around the world can be part of the public blockchain. What they need to do is, if it is a Bitcoin blockchain, you want to be a part of that, you go to Bitcoin platform, download the entire blockchain. It may take you a few weeks to make a copy of the Bitcoin blockchain, because it is just so massive, but nobody is going to stop you or ask you any questions. Why do you want to install? Why do you want to be part of the network? It is completely open. Anyone can join the Bitcoin blockchain. Anyone can join the public blockchain. On the other end, we have private blockchains or enterprise blockchains. And why do we need enterprise blockchains? Because we have confidential information that organizations do not want to share with public. Why does anybody else on the internet want to know who I am transacting with for my business? The only people I would want to know that information is those who are part of my business, my supply chain network. Those are the only people or entities should know that information. So to enable that, we need to have a private or a permission blockchain. So if you see the term permissioned, what it implies is you need to be permitted to be part of that blockchain. It is not like a public blockchain that anyone can come in. You have to have the right authority or access to be part of a private blockchain or a permission blockchain. And it makes sense, because if I am doing business, if I am an organization or an entity, I would only want to connect with people who are within my network of my business partners or my business supply chain partners. I don't want everybody else to be part of it, right? So that's why we have the permission blockchain as well. Okay, so that seems like the last slide for my presentation. So if there are any questions, you can put them up in the chat box. I can see a couple of questions here. We will definitely take them up in the Q&A session. I'll pass on to Shyam now.
Thank you, Vidy. Thank you for the great introduction. And Vidy, you will have to take that question from Ramesh Reddy on Bitcoin fraud example. How is it addressed through traceability? So we'll do that at a logical break, or if you want to do it now, we can do it.
We can take all the questions at one go.
Yeah. Okay. So hopefully you people are enjoying the session so far, and hope it has been informative. And we'll step on now to get a bit deeper into how blockchain has been able to transform the industry. So let's get going from what Dr. Vidy has shared with us. Blockchain, essentially, remember it as a database, a more complicated database with more functions in that. And second important point Vidy spoke about was the value in collaborating, value in the whole network in which you are participating, or value in the ecosystem. So remember these things, and then we'll be ready to go to see what transformation blockchain has been able to bring. Okay, can we have the slide now?
Yeah.
So let's get to the next one. And the first question is, we all know that blockchain is a emerging and a disruptive technology. So everybody wants to blockchain. But the first question you need to ask is, do you at all need a blockchain? Or when is a blockchain very appropriate to have? So number one is there are set of questions. Today I have only put a few questions, but this is the assessment we do basically to figure out whether blockchain is really needed in a particular ecosystem or in a particular industry use case. So number one is, do you need a, a common database or a common data structure or a common data set across different organizations? Are there multiple parties involved at all? And if there are multiple parties, if it is yes, 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 then you are going more towards a need of a blockchain. But if you have answers which are coming no, then you reevaluate whether you actually need a blockchain or not. The third point is, do you have a lot of parties in which there may be conflicting incentives, or there is a question of trust? So if there is a question of trust, you know that blockchain will place the trust in the network, show exactly the consistent data across the participants in a blockchain network. The fourth one is, are there different rules that govern different parties in a blockchain? And that's where the smart contracts, which Vidy has spoken, will come. So basically, what happens is, party A transacting can have a set of smart contract. Party B receiving the transaction needs to do something else, will have another set of smart contracts. So you keep writing smart contracts, if then statements, to make the whole chain effective and the transaction across the chain effective. So this is where blockchain really works well, right? And the fifth point is basically, do you need traceability of the records? And do you need basically immutability? So immutability is the inability to change any of the records without without getting to notice basically what has been done on the blockchain itself. So if there is any change in the record, then you will literally see that the whole blockchain is rendered ineffective after that. So you can't post any more transactions, and that's how it stops anything to go into the ineffective chain or a muted or a blockchain which has been changed. The sixth one is, you do have smart contracts, you do have rules of the transaction, but these rarely change. So if that is the case, then you put the rules once and then basically follow through. If these are all yes, then you think that there is a case for a blockchain. Now, the other thing is, if trust within the network and data security is important, then most likely you would blockchain it, right? Another way to think blockchain, and this is now because we are going into the next session, is to say that you have heard about ERP systems in the past. What does ERP system do? ERP system, or the enterprise resource planning system, used to provide an integrated platform for an enterprise, for one enterprise. So it used to connect the various departments or divisions of the enterprise, which is procurement function, finance function, manufacturing function, engineering function, quality control. All those functions used to see a common set of data across the enterprise. So that's why it was always called as the integrated ERP system, wherein if you if you raise a purchase order, then a signal goes to the account payables saying that, oh, purchase order has been raised for $100. So I will have an account payable to be made based on the purchase order term, which is say 60 days payment. So after 60 days, account payable needs to pay against that purchase order. And so the ERP system will trace basically this purchase order has been placed by manufacturing department to this party or to this supplier, and that supplier needs to be paid in 60 days, right? So when you have a system like that, then the enterprise was able to see a integrated or a uniformity in the data. Now imagine blockchain as an integrated ERP system across a set of enterprises or a ecosystem. Then blockchain exactly does what a ERP system does within the enterprise. So imagine that, and then you will be able to realize is blockchain is ERP system for multiple enterprises who will see a common set of data, common set of rules, and common set of transactions within themselves, right? Okay, so let's move on to the next one and then see. So, what happens in a blockchain implementation? You know the difficulties people have faced in a blockchain, in a ERP implementation within the enterprise. Organizations have spent multiple years in order to do an ERP implementation only in one enterprise. So, blockchain is across enterprises, so it will be naturally more complicated. So, number one is, have you figured out basically who are the players who need to participate in a blockchain? Okay. Fortunately, they are also called as actors. So, not the film actors, but basically these are the blockchain actors or the players in the ecosystem. So, have you identified who all need to be there in the ecosystem? Have you signed up with all the players? Do players understand their roles and responsibilities? And uh, they have signed off to say, yes, I agree that blockchain will be done. Third one is the real issue in a blockchain. Who owns the overall responsibility to operate the blockchain? Is it the leading player? Is it a player who benefits the most? Is it a consortium or is it an independent party? And why you need to do in a certain way? This is where the whole architecture, the hosting, the responsibilities come in a blockchain implementation. Okay, you have to understand that now you are talking about a consortium or we are talking about a multiple players who will be seeing the same system, and who do you trust in order to run that system. Okay, now the next one is, do you, I will put it the other way, do you know how to get to a process which will be on a blockchain? Because the processes will completely change between how it used to operate before and how it will be operated when you are on a blockchain. And I will explain you these through examples immediately after this slide. If you have not done the 2B processes, or if you are going to depict the same processes what you are trying to follow now on a blockchain, then it will be most ineffective to implement a blockchain because you are not going to get any benefit out of that blockchain. And what platform will you use? There are so many blockchain platforms today. There are so many ways in which you can apply blockchain, whether you want permission or you want public or you want federated or you want a hybrid. Sometimes there are cases which are certainly going towards a hybrid blockchain, and I'll explain you through the examples in the deck to come. Do you have a target architecture and roadmap how you will get from a current situation to the target situation? And obviously the most important one is the return on the investment. Have you worked out the blockchain economics in the sense that if there are 10 participants in the whole network, do you know that what is the amount spent today by the 10 participants? What is the contribution each one makes today to the supply chain? And how these will work together on a blockchain? And then do you know who will benefit the most or who will benefit how much out of the 10 participants in a network? If there are benefits coming out from the whole blockchain economy, then how will you distribute those back? Because I may be the one who is least benefited and I will not have a reason to join the join the whole ecosystem, and I will become a bad actor in terms of making this blockchain effective. So, what is very, very necessary is to understand how will you pass the benefits of a blockchain back to the participants. Does the blockchain also generate any new revenue? There is a possibility that blockchain will develop new revenues. You have to identify that upfront, and then how will you distribute the new revenue among yourselves? You might have also heard that blockchain reduces the need for intermediaries. Um, if you have not, we will see basically some of the examples where how blockchain will reduce some of the middlemen and allow organizations to trust and talk to each other. Now, the next one is how will you migrate from the current processes to the new processes? What change is needed? And is that change enabled by all the organizations? And finally, if there are regulatory authorities uh, who are needed to be informed, who need to approve, even if there are cryptocurrencies involved in the blockchain. I think all of you know that there are a number of regulatory approvals which we need to take. If there are payments happening, if there is a transaction happening in terms of which has monetary value, then I think we will have to even inform the regulatory authorities. The good thing is the regulatory authorities, the auditors also become part of the chain, and we'll see examples of that. Okay, so I hope that this slide will tell you a good way of how you need to implement or go through a blockchain implementation itself. Okay, come, let's move to the next one and see what do you typically do, or what stages do you see in a blockchain implementation. Most people are hopefully aware of steps you need to undertake in a system implementation, be it a custom development or an ERP or a CRM or any of those. In a blockchain kind of environment, the first thing what you need is a reimagination and a strategy, where you reimagine to basically say, what was my old way of doing things, what is the new way of doing things, and how blockchain can support to address the new requirements and to bring benefits, or address some of the business challenges which I am facing today um, in my whole say supply chain, or in my whole transaction network. Second thing then you do is build a strategy, develop basically how you want to get there. The proof of concept is often the most used way of going through a blockchain implementation, where you say is, I want to test it out, whether what I am saying against the requirements really works the same way in a blockchain. So you get the concepts evaluated in stage three, and if you are convinced that yes, it is working well as per what we had designed, then you go to a pilot. And in the pilot, basically, you say is, I want to involve a portions of the organizations involved and see whether this is really working in a production environment or not. Once we do that, then we scale it up across all the environments. Expand and manage is really a term, because blockchain will give you transaction capability, but apart from the transaction capability, like Vidhi said at the beginning, blockchain will give you transaction processing, but we need something on top of it to give you the must needed analytics at the end of the day. Blockchain you will see with IoT, where you bring a IoT information along with blockchain. We'll show you some real case today. You will also see AI or automation sitting on top of it. Why do you need AI? Because now you are bringing a wealth of information or data together across enterprises. If you don't apply AI, then you have lost the whole cause of actually bringing so many players together and not getting AI out of it. So AI is needed to run your analytics to say is these bunch of enterprises working together can do much better if these things are happening. So AI works on a blockchain most of the times, and I'll give you some example, especially in the energy area or in quality of crops, agriculture, etc. Okay. So I will not go through the detail, but you typically have an analysis and design phase, you have a build phase, you have a deploy phase, which is very similar to what we do today. If you understand the stages of the blockchain, then the steps needed or the activities needed in each one of the stages what defined. Basically, you confirm the overall objective, you do a functional design document, you do a stakeholder mapping, you collect requirements, you design both backend processes, how the screens are going to look, and then you define the whole security, access, authorization, and the blockchain architecture. Basically, now you need to see who can see what set of data, access what set of data, and why. And all those things you do actually in the architecture. Then you build the infrastructure needed for the architecture, test it out, and then you deploy. So that typically works out the way in which you go across the blockchain. So while I have given you the flow, I will want to show you what really happens in an entire blockchain cycle in the next slide. The methodology you will need to go through and what are the key success factors. So usually you have to be very clear on the feasibility study and what opportunity you are pursuing, and that's the blockchain steps which I have told you about. Have you made the right selection of the platform and partner? If you have not done, then you may get stuck somewhere. And have you really created a case for cross-functional and collaborative approach? Remember, the core value of blockchain comes in being in a collaborative network. If you are not in a collaborative network, the blockchain doesn't give you the effective uh, benefits of the one. Do you know how you integrate processes and systems across the enterprises in a blockchain? Now, I'm taking you again one step further than whoever has done enterprise resource planning (ERP) implementation, where you talk about integration of systems and processes within the enterprise to across the enterprises. So these are key success factors which you need to think of in going into a blockchain implementation. And now let's look at very holistically what could be a methodology applied in the whole implementation of blockchain. So you begin with objective setting. You do a number of steps in a discovery workshop where you do ideation, you do a point of view, you compare what else has happened in that industry, what pain points are being seen and unaddressed in the industry for a long period of time, and then you compare whether blockchain gives you any edge compared to the traditional IT, or blockchain enables you to put a platform on which AI could be very effective, on which IoT could be very effective, and a combination of technologies can give you the benefits. So you do ideation around all these things and the customer journey maps, right? How it used to work in my past processes, how it now works in a new process. And you ideate, you exactly create a customer journey map to see is how does various blockchain actors see and feel the new blockchain system in a network. So this whole idea, you create empathy maps, you create customer journey maps, and you ideate, and you come to a set of use cases and a prioritization of those use cases to say that this is what looks ideal thing to do in my industry, in my ecosystem, whether it is pharma, medical, whether it is energy, whether it is education, whether it is finance or supply chain or wherever you are. So this discovery workshop becomes a very essential part where you involve the players, you involve them, you invoke ideas from them. So then they automatically become supporters to the implementation of a blockchain. But if you come out randomly with an idea and you don't have the blessings or support from the actors of a blockchain, then you fail in the adoption part of it. You fail in a ERP system, in a CRM system. So failing in blockchain is also pretty easy if you're not doing it. So think from a change management perspective upfront. Then, once you have finished your discovery workshop, you go towards the POC and in a proof of concept where you do prototyping, you test it again and again and again, and now you create a storytelling, right? You do a stories for how a pilot or a production implementation or in a real life scenario, how the whole new enterprise set will work together in in the in the blockchain environment or blockchain plus uh, other technologies coming together. So you do a proof of concept, then you go to the whole implementation. And I have literally listed out the number of activities which will happen across. So this is very comprehensive. That will give you a whole set of things. You don't really miss anything at the beginning of it. Yeah, or at the beginning of the journey, or at any point of time, taking all the prerequisites needed for implementing the blockchain. Okay, so what I covered till now is mostly around how you go about implementing the blockchain, assuming that all of you have now an understanding which is usually implemented when it is between parties and multiple parties are associated with implementation of a or usage of a blockchain. Yep. Okay. Then let's get to the next one. Uh, you know what blockchain is giving. Now let's see what industry is requesting for, right? And you have already seen some of the blockchain features. So what industry wants is basically a very strong governance at the end of. So if you are implementing a process or a system, industry always wants to govern that very strong. Even the regulation wants a very strong governance to see an audit trail of the functions or the transactions which is happening on the blockchain itself. The controls on the access of data, on the implementation of new data, or how a particular actor is able to deal with the data. Either he is going to see only, or he can write, or he can update, or what he can exactly do, he or she. Compliance with regulatory requirements. Okay. Now, this is the most important function in a blockchain solution. What happens is today in banks, today in telco, today in most of the supply chain, you deal with regulatory requirements very independently. Very independently means you know how much of money banks spend on doing regulatory compliances. Basel 2, Basel 3, or SOX requirements, all these things are outside the system. They build a set of people to work with, they build systems for doing this, and then they report back on a regular basis, even pharma. So now in a blockchain, with this kind of a traceability, think whether you are able to minimize or completely eliminate a new system for doing your regulatory requirements or compliance requirements, because you have got everything in this, and I'll show you examples as we move along. The next thing is standardization. The whole industry suffers from having different definitions of different things. Even when you do parts transaction, the parts are known by different names and different part numbers, different identifiers in various organizations. you end up in mapping all those between the enterprises. But now, because it's a shared ledger, it's a shared data structure, you can actually have a common definition across the chain. So a screw is seen as a screw with the same specification, with the same dimension. Okay. Security, yes, we have spoken about it, the authenticity and the security. Then the next one is the reliability. So now everything now what happens on a blockchain is reliable. I'm not saying that blockchain is completely tamper proof. There are ways in which cyber security attacks are even happening on blockchain. You have heard about a couple of stories by now, I think, about how uh, even blockchain could be impacted. And I think blockchain platforms and companies will continue to work against that, right? And they will continue to prevent any cybersecurity attack on that. Now, whether these are scalable or not, I think if you have seen or heard, the biggest problem today blockchain was facing was around scalability. It was okay to do a set of transaction in a given time. You know how much of time is taken in order to build a new block, in order to mine a block or mine a transaction. It takes time today. It is not like an enterprise system or a or any other transaction system today we see either on mainframes or on Unix servers or Windows servers, where it runs many TPS number of transactions. But we have to we have to create the scalability as we go along. So scalability has improved from what it was before and what it is today, and it will continue to build that. But what you really bring onto a blockchain platform is keeping everything in mind. You don't take a very, very high transaction processing onto a blockchain knowing that it can be a deficient, right? Or it can be a deficiency. So you build basically where you need a scalability which blockchain can address. You have governance, you have regulatory needs all met, you have trust around the network. So remember this, okay? Allow me to have some water. I think I am going dry. Yeah. Next slide, please. And this is the busiest slide. And this is most probably the informative slide for all of you. Okay. So we'll go one after another, spend a little bit of time. And I am looking at the remarks. If anyone wants me to speeden up, I can speeden up. But I think this will give you basically a lot of information. And yep. There was a particular strip which was coming into my slides, so I have done that. Let's look from top right hand corner, the government. And now I am talking about every industry. And I want all of you in your capacities, whether it is faculty, whether it is the audience who are working on various enterprises, various organizations, to understand how blockchain could impact in the organization you are today. This is not a comprehensive, exhaustive list, but I think it is good list to begin with. And today internet has got a lot of information. You can actually pick up a document which will show you 100 use cases, 200 use cases, etc. But today I'm going to talk to you about some of the very practical use cases we have seen. So wherever you see government, public records, public stat organizations, pseudo public organizations, think about blockchain for digital records, validated, authenticated digital records. Think about blockchain for a vehicle registration. And today I'm not covering vehicle registration, I guess. But imagine today when you buy a vehicle, how many organizations do you need to go to, and then how disconnected these organizations are, and how many times you need to go through the same set of documents, carry from one place to another in order to complete your vehicle registration, and then report it back also, so that the road tax payments, the insurance payments, and the licenses, and the whatever documents you need for the vehicle comes together. But if you imagine vehicle registration process on a blockchain, it becomes very easy. The most famous one in India right now, land and property, where everyone would have experienced about the difficulties we face or consumers face in the land and property, where titles are not clear, multiple parties take claim, you have issues with the area you have brought versus area you have gotten, right? At the end of it, the surveys and all that stuff. Okay. Now, uh, if you put any property transactions on a blockchain, you would know that everybody, all the regulatory organization, whether it is the registrar, whether it is the revenue organization, whether it is the buyer, the seller, the bank, or the financier, and anybody else involved in the whole gamut of things, all are on the same platform. You would exactly know what is the property and what is this property going to do, and where is it transacting from and to. So you get the complete information of the property on a blockchain much more clearly. And you know that several states have already begun this initiative. Gopal and Sai have also come from a similar background, and they were responsible for creating the system for AP government for doing the land registration and land transaction. From a government perspective, B2B licensing or business to business licensing is very important. And I will show you very quickly one use case as we go along. And notarization. Today, a number of people have a need for notarizing the documents. If they are digital records, then we can have digital notarization. And perhaps this is going to come very soon to say that we can completely eliminate the physical notarization and have digital attestation of the documents needed, first of all, if it is needed, because blockchain already have authenticated records, right? Now, in the same ways, anything around copyrights, anything around IP, whether it is government, whether it is any other organization, pharma, for example, all of them, or you have media and entertainments where entertainment where you have digital rights. So all these rights are a very good use case for a blockchain because it gives you the complete authenticity and the originator of the particular IP or copyright we are talking about. Voting, I'm not talking about EVMs here. I'm talking about the real voting. And that voting is again possible as on a blockchain platform because no one can then tamper the records we have. Even government auctions, and if I include the finance industry, how many bad debts are going around in the country, and whether if all these auctions come on a platform, then it is a perfect way of dealing with selling any of the non-performing NPA, what we call today NPA assets, at a right value. So all those things could be on the government blockchain use cases. Let me talk about energy management next, the one below, where number of initiatives are coming around peer-to-peer energy trading. These are applicable for more of the markets where energy is deregulated, energy or utility deregulated, and where people are measuring carbon credits and etc. So where there are microgrids coming up, where grids exchange, buy sell, multiple buy sell marketplace, those are the places where blockchain has been very effective. And somebody asked a question earlier, and then we'll be responding to that in a Q&A session on what we are doing around microgrids and what area of research we are handling today. The supply chain has been most effective in blockchain, and you would have heard about numerous supply chain cases, whether it is Walmart and whether it is the luxury goods manufacturers, whether it is Boeing, the aircraft manufacturer, all of them tracking their parts, tracking their supply chain, and tracking the goods around the supply chain for various reasons, right? It could be to see that every party has done their transactions on time. It could be to make sure that the goods which are there are authentic, and it could be to verify the original manufacturer at all times so that you don't have any counterfeit. And making sure that the asset transfer is more and more effective. And all of us have heard about organic food, or the initiative like Grow in Australia, what we are doing today with Curtin University. These things are also coming on blockchain in a big way, where you can literally see up to the farmer level who was the farmer to produce that particular crop, which batch it is, which site, which location, and you can even see what kind of resources the farmers have used. Organic, recycled, for example, renewable energy or recycled water, something like that, right? So all those informations can also be seen to see the sustainability index of the whole network. Shipping and logistics, I think the most popular area. If you people have heard about TradeLens of IBM, which I think is the biggest today in terms of shipping and logistics solution on blockchain, where they claim that over 70% of the trade can actually happen on the TradeLens platform. Supply chain financing, which I'll be talking through very soon, where blockchain is very effective. Okay, let's go to the gaming and video. I've spoken about it. Wherever you have digital rights, whether it is media, digital media like music, or whether videos or gaming, and any art or any kind of fan tracking, auctions, etc., are very good ways of tracking on the blockchain itself. Pharma, it is of interest because there are a number of patents where there is confusion. There is a combination of pharma companies who are involved in up to their level when the commercial drug comes, because somebody else has developed a formula, somebody else has done some other work in mixing, matching, and doing the clinical trials, etc. But then the whole pharma effectiveness and on the patents and IP management is basically when it is on blockchain. And you can see the second last point, proof of existence, is proof of research being conducted. An associated terminology on blockchain is proof of work. And we'll get to know about these things as we go along. So you literally need to prove that your work has been completed, and here it is, the output of it. You might have heard about genomic data coming on blockchains to track basically the heredity. And I'll talk about returns management in a use case later. Let's look at healthcare. And all of us know basically on healthcare, how much of data do we actually know by ourselves? How much of digital healthcare information we have? The PHI is that personal health information, or the electronic health records which we have, or the electronic medical records. In some of the countries, you will not even get back the documents unless you literally ask for. Okay. Now, if you put everything on a blockchain, then on my mobile, I can actually have all the information I need, and then I can decide to which doctor I will share what information. So you imagine you are going to a new doctor and you have never visited before, and then you want to show the history of the diagnosis you had, history of the drugs you have had, or any allergy, or what else happened in the other hospitals or other clinicians. You can do all that on a blockchain because you can show a whole trace of the transactions which you have done. Healthcare has number of compliances, HIPAA compliance in US and every country almost. So you need to do that, and you have blockchain to give you all that automatically. DNA sequencing or the genomic data I have already covered, and I wanted to also share how you can transform a particular industry within the larger sector, right? All of us know about blood banks, and most of us are involved in donating blood. How many of us know where the blood has gone? Almost none, because the blood, once you have donated, is taken away. There is no more traceability to say that this is your blood. It has been broken into components sometimes, or it is being transfused to somebody you are not aware of. You also, it is important to know that today, although donation and campaigns are mostly free, right? A lot of blood wastage is there today because people do not, at the receiving point or at the demand point, people do not exactly have the same blood which is needed. That's why you keep seeing the messages in social media. I need A negative, I need AB positive, and all that stuff. So a blood supply chain has not been very effective to connect the entire ecosystem. So now look at it, that if I am a donor, I know exactly where I have donated my blood, and I will exactly get to know where my blood has been used, whether it has been used to in a transfusion process, or whether it has been broken up in components into platelets and that platelets has gone to somebody. I will exactly get to know the whole sequence of it. And you connect the receiver, recipient, and the donor, then it can become very good, right? And then you introduce basically a reward system into that. Because all the recipients of blood transformation, they pay a lot of money to the hospital, but the donors don't get anything. If you need to promote blood donation, then you can actually reward the donors also. So this is the kind of things which we can think of. And the last one, the elder care. In many of the countries, elder care has been a problem, or even chronic diseases have been a problem. To follow through, basically, what is the treatment which needs to be undertaken, whether those have happened or not timely, and to keep informed the family members. So, suppose, imagine parents are here, they are old, they have chronic problems, the kids are in US and they're trying to track this whole thing. You have the organizations today who do elderly care, but putting it on a system to say that today my parents were supposed to take this drug, they have taken it, these are the feelings they have, this is the side effects of the drug which I have seen so far, and all that stuff today on a blockchain is a very useful case. Yeah. Let's deal with education, because we are with Curtin University, we are with NIT Warangal, and various other area institutions where we are teaching blockchain, we are doing blockchain projects together. Imagine a complete student life cycle on a blockchain. So you exactly get to know how a student has come into the university, through what scheme, through what entrance exam, based on what, and based what was his rank, from which domicile, and which branch has he joined, which batch has he joined, and then what he has to go through the whole thing, right? All the academic certifications which today are physical could be actually put on a blockchain. So this can become a lifetime, basically, digitalization of records, right? Right from Aadhaar card to birth certificates to education certificates to professional certificates to up to the death certificate. So the whole digitalization of records could be actually coming in in the government sector, in the education sector, and in the professional sector, and those regulators who manage basically the birth and death, right? You can also have a digital currency introduced for all the transactions which is done in a university. Why do you need to have cash transactions? I know there are payment companies today. A lot of Paytm, Google Pay, etc. is used today. University can have its own coin. That coin could be representative of a particular value, and that value could be stored into the coin. Another way to look at it is also a reward scheme for the students. So today, how do you better engage students in the college? If a student is achieving say 80% plus, then you give him a coin, an extra coin or 10 coins depending on the value of the coin, and then allow the students to even redeem those coins against something. They can redeem against coffee, lunches, or they can redeem against offsetting the tuition fee, or even having more more important things than having 1 hour of guest lecture from a professor one-on-one or something like that, and which we are actually designing with Curtin University to introduce a coin which is a virtual coin and which will go into engaging the students better. And we are going to see and pilot it with say 200 students on the blockchain, 200 students off the blockchain, to say is how we can actually see the difference in the way students have engaged, the ones which get rewarded and can redeem those versus the ones who don't get rewarded, right? And this can be basically not even the scoring, it could be attendance. Most of us are aware, right? We have been backbenchers in our times. So attendance 60%, if that was the minimum, we used to achieve 60%. But if we think that attendance is one of the prime requirements, whether it is physical, now whether it is digital also, right? So virtual, all these things are now a very good way of rewarding students and to make students engage better. Assignments, a number of assignments, you know how many follow-up processes happen in an assignment submission, etc. You can think about putting that in a blockchain, rewarding the students against to get better engagement from them. The whole learning management again of a student in a life cycle could come on a blockchain. Yep. And getting on to the last one, the financial services, from where most of the blockchain initiatives have started. You have heard about all the cryptos. You know how many cryptos have come, how many cryptos have died. I don't know how many people have involved in crypto transactions, how many have lost their money, and but you know that people could have made money when Bitcoin was say $500 in 2010, 11, 12 to 26,000 or something for a Bitcoin in 2018, 19, before it went down, and I think today is about $10, $11,000. So a lot of fluctuation, lot of avenues to make money. And you have crypto exchanges where you can buy, sell cryptocurrencies. You can put all kinds of currencies. You can put a basket of currencies with a platform which we had originally designed along with a friend of ours called Wand. It was Wandex, and where we developed innovation to say that you don't do a one-to-one crypto, but you can actually define a basket. I've got 0.5 Bitcoin, I've got 1.23 Ether, and I've got Litecoin, I've got other coins, and then you prepare a basket and sell the basket. Yeah. Payments, settlements, KYC, anti-money laundering, crowdfunding, peer-to-peer lending, asset-based securities, audit compliances, collateral management, and all those have been very effective on the blockchain. Audit compliance is something which I would like to pick it up. Basically, in an environment where last 3 months, I think no physical involvement, and in the next 3 months also limited physical involvement. So if you had a audit, if you were an audit company, or you were a organization undergoing audit, or if you are doing internal audit of your organization, if you had everything on a blockchain, today you could have done a digital way of audit. You would have done the same result of a audit as you do on a blockchain as you do physically, because you can go through the compliance. You have immutability of all the RFIs which are raised in an audit process, and for the the additional RFI which is raised by the auditor, and at the end of it the audit report comes, and then you can justify. So every team, every company could be defined, the roles can be defined, and then you go through the whole audit and compliance process of internal and external audit on a blockchain itself, right? And coming to the insurance, all of us have heard that several millions of dollars are lost in insurance claims. Yeah. Whether it is medical insurance, whether it is motor vehicle insurance, whether it is health insurance or life insurance or any other forms of insurance where there are claims processes. Bring the claims processes, bring the whole network. Who are the agents who could be involved on the claims, on authorizing the claims? Today, we do claim management, but we don't use the authorized dealer or the repair agent for a particular automobile involved in accidents, right? We'll go to the nearest one, but we don't follow an ecosystem where you have basically all the authorized agents. You put the authorized agents by company, and then you put the insurers, you put the consumers onto the same chain. Your fraud is going to be literally zero. So anti-money laundering, any fraud you want to track, this is the best platform to have in order to do this. Yeah. Okay. So I think I spent a lot of time on this, and I am nearly about an hour into my time. So let's go to the next slide and see some use cases now. Now I will take you through. I hope I am making sense. Technology can be learned very quickly. If you want to know how to build a block, a techie guy will tell you very quickly how to build a block. Almost all of us have a capability to build it on our own laptops. Okay, it's so easy. But how to implement, how to go about looking for use cases is most difficult today. Yeah. And so this is what we are trying to distribute to all of you. Hopefully through the use cases, I have passed on the messages to the various faculties, whether it is today, because there is no direct linkage between the academic streams and the industries. So you are in electrical, mechanical, comp science, electronics, metallurgy versus the industries you work at. So there are a combination of industries where you can work with, right? I never knew that I'll be a mechanical engineer talking about all these things, right? So at least to understand is how a particular course could be enhanced, or how blockchain could be interacted along with a particular course is very important for the faculty to understand and tell the students, right? So now let's look at what happens in a typical purchase to pay. There are a lot of you who will understand the whole purchase to pay or P2P cycle, not peer to peer, but unfortunately both use the same terminology. So the current situation is, if you look at from the supplier and client the two boxes, and you will see various arrows, right? So the client raises a PO on the supplier. Supplier will acknowledge and then also send the goods and shipment notification. And then the client will initiate a goods receipt note. And after receiving the goods, he will acknowledge back to the supplier. There is the invoice sent. There is a whole inspection process, and there could be a rejection process, which I am not dealing with today. But even without that, imagine the level of complexity we have. Then there is a verification and the payment process actually happening. How does the whole payment happen? There is a client. Client has its own auditor. Supplier has its own auditor who is different. Client has a bank. Supplier has a bank. Banks will have their own auditors also, right? Which are totally unlinked into the ecosystem. The bank between the supplier and the client are also not linked. And so client requests his bank to pay to the supplier, and then the transfer happens, and then the supplier needs to re-verify whether the payment has actually come into the bank. In this, there are some things which ERP handles automatically, right? So three-way invoice matching, the payments can be automated, the acknowledgements can be automated, and number of things could be automated in this processes. Lot of innovation has happened already matured. But the things which it doesn't do today is connecting the auditor 1, 2, 3, 4. The 4 auditors are not connected. The 4 audit processes are not connected. The banks are not connected. And the number of processes today they follow, and the number of errors which they face, and the number of processes or interactions they have, more than 20 for just a purchase to pay. You can imagine how many follow-ups happen. All those who are in production, all those who are in purchase will know how many times they need to follow up from their suppliers for material, for payments, for all the processes, right? Now, if I put everything on a blockchain, right? Now you know this particular thing has got how many actors? You got a supplier, you got a client, you got 2 banks, you got 4 auditors who may be participating in internal, external audit process. So let's see what happens on a blockchain. Okay, in a blockchain, you have a blockchain record that is the middle line, right? So this whole set of records what are raised through the cycle is maintained in a blockchain, right? And the access to those records can be created multiple times. So you have, first of all, a shared ledger, common language spoken across the line. So as soon as the purchase order is raised, the purchase order is placed in the blockchain, the concerned parties will be able to view the purchase order. You don't need to send it anymore to the bank, to the shipper, to the client, or everybody else, right? And the banks will know, the auditors can see anytime what they need, right? And the terms of the purchase order get into the blockchain smart contracts. So suppose your purchase order was 60-day payment term, and if you have volume discounts, all those things could come on a smart contract so that the settlement of the purchase order and the payment is reconciled. Now, release of letter of credit. So LC is released by the bank, and then that is sent to the supplier bank, and then the shipping actually happens. All these documents are now stored on the blockchain, and as soon as the particular activity happens, I can trigger workflows for the next activity to nudge the person who is supposed to do the next activity, and then simplify the whole process. Today, you don't need to follow more than 20 processes. You don't need to do number of repeat reminders, and you don't have errors today. So that's the importance of putting everything on a blockchain, right? Hopefully, this will show you the advantage of things put on a blockchain. Today, I have started with a very small process, purchase to pay, and this is only showing you a very simple process. In my next one, I am going to complicate the case and take you through in what happens in a more complicated cases. But you need to give me a small break to fill up my water. I need it very badly. Next slide, please. I'm back. So all of you know about shipping, right? Shipping industry. And so I'll give you what happens in a shipping industry. There are about 30 participants and hundreds of documents are verified multiple times and completely prone to failures. So look at the look at the ecosystem. You got a shipper or a supplier and you have a customer. So end to end that is done. But in between you have local transporters, you will have freight forwarders, then you will have the customs, the ports and the shippers, and it arrives to the receiving port and the customs. You will have bonded warehouses, you will have the port authorities, the shipping terminals, the shipper and the container handlers, and now you have got the clearing agents, you have got bonded warehouses, you have got local transport before the goods come. You will be surprised to note how many times each one of the regulator needs to see the documents and how many copies of the documents are printed again and again and again through the whole cycle. So look at the documentation, right? You have a goods shipment notice, you got supplier licenses, you got packing lists, you got insurance, quality certificate, invoices, letter of credits, purchase order copies, and including the certificate of origin, right? These set of documents and perhaps more, right? These go through multiple verifications. They have to address the country regulations. Somebody asks for more documents, you have to do that. There are documentation errors and everything is paper based. So you need to keep showing the same set of reports multiple times, right? Now this leads to errors. And if I put everything on a blockchain, look at how efficient this can be, right? So you got seamless integration and you get enormous amount of efficiency gain, and then you have literally zero errors, and you have paperless in the whole process. So you have common set of documents. Every document which is raised once, but it is used across the whole chain. Yeah. So if the purchase order is raised once, that is available for access, and we control basically how the whole access is to be given. So the moment we do this, then the entire cycle actually sees the same information. And this is where I think TradeLens, what I have spoken about from IBM and other shippers are trying to build on, right? And this is perhaps the most important use case in the blockchain, right? Come, let's move to the next one. So let's look at pharma. And for those living in the US or familiar with US, MediLedger has started off an initiative in US for Drug Supply Chain Act, where basically there is a mandate for tracking the entire drug cycle, right? And including the return of drugs. I mentioned this about returns. The returns of the drug also needs to be tracked so that it goes back to the necessary places or it is disposed in the right way. So again, look at from a drug perspective and how important it is today for all of us to have no counterfeit drugs in the whole cycle. You know how many parallel manufacturers are there today in Asia who will produce drugs look same but not effective, right? So from this perspective, if you look at a pharma company, right from certificate of origin, batch numbers, the processing data, whether you have barcode, QR code, everything is so effective that if you are at the pharmacy and you scan the QR code, you exactly know which batch, whether it is authentic, whether it is from the same manufacturer or not. You get the complete information of even how the whole drug has flown through the cycle. So from there to shipment date, the order number, barcodes or QR codes, certificate of origin, batch numbers, shipment dates, temperature, storage dates, everything, and how it has been shipped to from a regional data storage center to local warehouse to a retailer, all the way up to the farmer, right? So this whole cycle is so important. We can do it across the pharmacies, we can do it for a farmer, and the same thing is applicable to today all the food trust or even the Boeing, what they are trying to do for their spare parts, and for anyone who wants to only have genuine parts in their cycle, right? You want to eliminate anything which is possibility of a duplicate, whether it is luxury items, whether it is jewelry items, whether it is things like consumables, right? All of us are aware of printers and the consumables or paper. There are so many parallel manufacturers of light bulbs, right? LED bulbs. You have one side very branded. On the other side, you go to the local market, you will get bulbs of all kinds. So if you want genuinity and if you want the price premium for that, please put it on this, right? I will talk about organic food. Today, the biggest fraud happening is about organic food. Today, we go to the store, we pay a premium because it is written organic. But how many of us know that it is really organic and whether this is been organically produced and come all the way to the retail store? There is a bunch of people today operating to only put the stickers on the produce. So they repack, they put the stickers saying organic, 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 right? And all this we see and we pay a premium without actually getting organic food. So we don't want a situation to pay premium on organic food which is really not organic. So very good case for food traceability also, right? Let's see the next one. And I think this talks about the claims, and I have spoken enough of the claims itself. But the moment you have patient receiving care and the whole care process, the costs, everything is put on a blockchain, and then you exactly know against what, right? And today I think we have an independence of getting the claims written in the way we want. We could have gone for uh, uh, a different purpose to the clinician, but we could have walked away with the kind of bill or receipt so that we could claim. This is a very common practice which or fraud which is seen in the industry. But if we have everybody in the network, then all these become a history for you. Then the authenticity is much more, and then you can actually see the provider submitting the claims, the insurer knows what you are insured for or not, and all this gets validated against through the smart contracts. And at this point of time you can actually basically confirm and then do the payments to the necessary parties, whether it is to the insurance company or it is insurance company paying to the client or to the corporate based on the claims we have today, right? So this is the essence of usage of blockchain in the industry itself. I'll I'll perhaps give you one more use case, and then we'll follow up with demos, etc. Yeah. So supply chain financing, and a number of you are aware of trade finance networks. Number of you are aware of working capital loans, overdrafts, letter of credits, and the amount of money we pay for our working capital loans. So traditional process, if we have a 100 crore purchasing budget or purchasing capacity in a year, so we take working capital loans against that. We sometimes have overdraft facilities. We pay how much of interest to the bank, all of us are aware, right? Versus now, if account payables, account receivable, all these collaterals could be given to a trade finance platforms. Today there are trade finance platforms like Marco Polo, like Trade.net, or there are a number of other consortiums of banks which have formed consortiums to bring the trade into that, and they will finance all these purchases. What is the benefit of a supply chain finance? As a buyer, I buy from a supplier. The bank finances it and pays the supplier almost instantaneously in 3 days or 6 days or a week, as opposed to the supplier getting payment in 60 days, right? So the 60 days is shortened, so the money is available to the supplier much earlier. And yet, as a buyer, I can pay the bank in my same term. So if I have a 60-day payment term, I pay to the bank instead of the supplier in 60 days, right? So this whole process is happening in supply chain finance, which has brought benefits of up to 4 to 5% on the cost of capital or reduction. But you can think of even other innovations where you can get additional benefits and bring the cost of borrowing down by considerable amount today, right? And this is a lot of money we are talking, because trillions of trade passes through trade finance platforms, and the amount of trade which happens in the world today. If you are a sub-supplier, you are a supplier, you are a distributor, you are a retailer, the cost of capital, and this is what you get, and then you can assure that how much amount of benefit you can make in your whole working capital cost itself, right? So there is a trade finance platform which even NatSoft has prepared, and we are trying to approach the enterprises for them to get benefited from such an implementation, right? I think that is my last slide, if I'm not mistaken. Next. Yeah. So we will be approaching now the blockchain use cases, and we'll show you demos of some of the functions we have had, right? Uh, we are not trying to show you the real application, because real application is sometimes a little painful, because you have to log in, log out too many times, because your role play changes, right? Once you are a supplier, once you are a buyer, once you are a regulator. So what we have done is we have made a video which will show you key features of some of the stuff. And what we will do is we will explain you the slide itself, the use case itself, and then take you through the demo. Okay. Hopefully that will give you a look and feel of what was the case before, what was the case after, how blockchain has been implemented, how does it look like, right? And you would be able to really appreciate the effectiveness and the efficiency gain or cost benefit from a blockchain implementation. So Gopal and Sai will take you through the next wave. Thank you.
Thank you, Shyam. Sai, can you load the slides? Okay, so I think it was a very detailed and comprehensive session we have seen so far. Vidy has taken you from basics to the level of what exactly and how blockchain is and what are its benefits and all that. And I think Shyam has showed you a very comprehensive list of use cases which are popular in the industry right now. So in a way, most of the information about the use cases and all is covered. But me and Sai, we will show you some practical implementations which we have done at NatSoft in the past few years. And before we go there, uh, let me remind you, a couple of points which relevant points which Vidy and Shyam have mentioned in their presentations. So if you remember, Vidy said blockchain is a database, it is a data structure. And when Shyam was presenting, he said blockchain. He mentioned the reasons whether you need a blockchain or not. So he had a checklist of things which you have to go through before you decide whether you need a blockchain or not. So there were steps in the implementation, there were discovery, there was POC, there was actual implementation, the whole cycle. So all of that is a very lengthy and effort consuming process, after which a product actually a solution sees day's light. So me and Sai will take you through some of the solutions which have gone through all these phases, and we will explain you all along the important things we have seen. Sai, can I have the slide? While Sai is arranging slides, so let little give me a second. Okay, sorry about that. So so give you a little bit of background. So you have seen what blockchain is, you have seen why you need a blockchain if you have a business process where you see a need of blockchain. But practically, when you go out in the industry, in the market, in real situations, we need to understand a particular industry process and what it need, why it would need blockchain. And oftentimes the industry partner or the customer doesn't know what is blockchain, and he doesn't understand what value add or what new possibilities a blockchain can bring to the table. So in simple terms, if we want to explain what blockchain can be used for, so it is mainly used for three basic things. There are much more things for which it can be used, but at the base level, it is used either to store digital records. As Shyam was mentioning, there is a need of records in every industry, and there are like more than 300 exchanges of information between parties. There are more than 20-30 actors in some cases, and more in some cases. So the requirement of storing records is very strong use case for implementation of blockchain. Then second is exchanging of digital assets. So it initially started with Bitcoin, which is a digital currency, which is actually a digital asset. So people were transferring Bitcoins or Ethereums over blockchain network. Why we were doing that on blockchain network? Because it is secure, because it is a distributed network, and everybody has transparency to the transactions which are happening. So if a business requires exchange of digital assets between one party and other, then blockchain can add a lot of value in such cases. And the last which we can do with blockchain is executing smart contracts. As Vidy was mentioning, smart contract is something in a way in which you can program some of the business rules and actually acts on itself as and when a particular condition is met. So if your business has processes, some conditions to be met before a certain action has to be done, that certain action can be by building in a smart contract with that logic, and the smart contract will execute on it itself as and when the conditions programmed in the smart contract are triggered. So at the very basic level, we go with these three basic uses of blockchain to explore if an industry can use and benefit from a blockchain implementation. Next slide, Sai. So let's see each of these three in a little bit more detail. Okay, so now we are seeing the first one, the storage of records. So as you can see, basically record two types. One is storage of static information, that is records which are stored in a database, kind of a database where you accumulating records after record, and it is verifiable as and when needed. That means the records are stored historically. It may or may not be real time. So for applications, blockchain is useful. Examples of that, I think many examples we have seen, but to name a few: land title, food safety and origin, patent. I think we have seen this in previous part of the presentation as well. And the very next one is identity. So we have identity frauds and lots of frauds associated with identity when it comes to financial transactions or when it comes to assets and all that. So distributed ledger is a good way of handling identity records and avoiding identity frauds. Third is the smart contracts. As I was telling you in the previous slide, smart contracts will enable you to automate some processes which can be triggered based on actions of different actors who are involved in the transaction. So examples of that is insurance claim and equity trading, music releases. Music right is also a digital asset. So all these can be managed through record keeping on blockchain. Then there are certain record keeping which requires dynamic updation and verification data. So that is the second set of storage records which we can deal with. And these records are updated dynamically in real time and are available to verify any parties across the blockchain network. So drug supply chain is one example which Shyam already told you. Payment infrastructure, cross-border payments, insurance claims. These are some of the examples which previous slides as well. And blockchain initial coin offering, ICOs, wherein you generate funds using blockchain as a means of funds by doing an ICO, and all of the information required is there in a real time like blockchain and is verifiable in the network. So coming back to the next slide. Yeah, so this is the third use of blockchain which we generally look for. So there are different types of digital assets which are available, which are getting created these days. So first of all, defining what is digital assets. So digital assets are digital representatives of value made possible by advancing cryptography, distributed ledger technology. They are denominated in their own units and account and can be transferred from peer to peer. Example are your basically crypto tokens, which are backed by gold or any other real asset. So you cannot exchange assets, that easily if they are whether they are precious, whether they are property or something. But if they are tokenized and these tokens are freely transferable from one person to other in a P2P network, then it makes much more easier for dealing of those assets on a blockchain network. So if there is any use case where you can tokenize a asset and these digital assets can be transferred between parties, then it also makes a very strong case for blockchain. So what are the benefits of digitizing these assets? So there are no regional barriers. That means a person sitting in India can trade a digital asset with a person sitting in Australia or America. There are no middlemen. So there is no need of middlemen, which is actually needed in other practical situations. Increased liquidity, because you exchange value on blockchain network and both the parties get their value in real time credited to their account. So you have increased liquidity, reduced transaction cost. Obviously, when you make cross-country transactions, the transaction costs are very high. But if you are making transaction on blockchain and if you are exchanging digital assets on blockchain, then the transaction costs are very negligible. And convenient redemption. So if you have certain digital asset which you have transferred from anyone, you can conveniently redeem it by selling it to someone else for its value. So these are some of the important factors because of which digital assets are getting popular. Now we will take you through some of the practical use cases which we have done and implemented over the last few years. So we will, Sai, next slide. Yeah, so the first demo go through is for food and agricultural traceability. I remember Shyam had mentioned that we pay money for organic food. We don't know whether we are really getting organic food or not, because there are lots of unscrupulous actors in the market who will brand a non-organic food into an organic food. All it takes is put a new sticker called organic food and and sell it to people as organic food. So to avoid that fraud of organic food or any other crop for that matter, we can trace a crop on blockchain from the point where the crop is grown, processed, and distributed to the market. All the information from the beginning till the end can be stored on blockchain. And whenever a customer picks up a product from a market shelf, he can see the entire traceability from its to the shelf space by just scanning a QR code. And customers these days are very conscious. They want to take a product. They are willing to pay more for a product, which comes with an assurance that that is the product what they are paying for. So let's see how we have done that for a crop called hemp in Australia. So hemp is a crop which is regulated, and it is okay. Let's see the video first. Sai, can you improve the audio? I think you're on mute or something. Sai, you are on mute.
I'm sorry.
Introducing HiTrack, a unique industrial hemp traceability platform for Australia, brought to you by Natsoft in association with HempGrow. Whilst hemp, cannabis sativa, has been grown in Australia for a number of years, a combination of regulatory red tape and lack of direction has meant that farmers are struggling to capture anything beyond the local boutique market. Part of this red tape includes the requirement for growers to firstly gain the necessary licence, agree to inspections and monitoring by state government inspectors, as well as various environmental planning and approval processes. Even with all the regulatory requirements met, the economic proposition for hemp production has remained unclear. Though the world hemp industry has indeed proven economically viable, there is still a lack of confidence in the Australian market's ability to effectively scale to a sustainable size and consistent quality, which is limiting investment. Enter Natsoft and HempGrow, who after extensive discussions with stakeholders have a clear understanding that by tracking hemp from seed to store, farmers will be able to seamlessly meet basic regulatory requirements and prove to the offtake market that there is consistent supply capacity of quality produce. The data will also provide a feedback loop to the entire industry, highlighting opportunities for business refinement. In collaboration, Natsoft and HempGrow have created HiTrack, an integrated hemp industry tracking platform. HiTrack enables complete traceability of hemp from seed to offtake using a combination of digital technologies, including blockchain, IoT, and machine learning. The platform will enable onboarding farms to record all data pertaining to their grow license, import permit, import license, location and inventory of seeds harvested, along with relevant document copies for their records. HiTrack will onboard the farmers and their teams with biometric information for entering and recording the performing of specific activities on the farm into the system. It will also enable crop creation and management from sowing to offtake, growing, flowering, harvesting, drying, packaging, and storing of the output for sale to buyers. The tracking of inputs and outputs at every stage can be precisely recorded via our QR code-based seed tracking and sowing, and when harvested seeds are placed into silos for future sales. HiTrack will generate notifications to the regulator on sowing, flowering, and harvesting, which will include geotagged photos and pre-filled forms. IoT will be set up to record temperature, moisture, humidity, and water during the 6 to 16-week growing process. In addition, this is captured while the seed is stored in the silo as well, and send this information to HiTrack, enabling recording and analytics. The blockchain backbone then provides total traceability of each seed package coming in for sowing and leaving the farm post-harvest. The traceability of stocks via QR code is a significant development, as currently no such solution exists, and everything has to be recorded manually, making it untenable. For every seed bag coming into the seed log, a QR code with detailed information on the origin, variety, exporter, and seller, along with a unique inventory identifier, is created. While sowing, this QR code can be scanned from the bag to record the seeds used, and a crop is created in the system. Subsequently, all activities related to this particular crop are recorded on the platform, and post-harvest, once the seeds are cleaned, dried, and packaged, a QR with all this data is generated for every bag of seed going into storage. Here's a quick look at the high-level platform structure of the intel that is captured and tracked at different stages, and which can then be viewed by scanning the QR code on the packages of the harvested seeds. The integration of this system will also make it possible to capture information pertaining to the buyers of the seeds and the purpose for which they will be used. With this knowledge, we can also plan for onboarding the buyers on the platform. This also paves the way for possible integration with their system in order to track the end product into which the seed is going into. The benefits to farmers are numerous. Makes compliance hassle-free. Provenance of the whole chain of activities, from purchase of seeds to offtake. Able to record and monitor temperature, humidity, soil moisture, and weather data, providing analytics that can help repeat strong crop performance. Provides historical data for compliance and planning purposes, and saves time and effort by autofilling data for form submission. They have geotagged photos of the crop at various stages, along with the generation of notifications for the regulator. And they have unique identifiers for incoming seeds and outgoing produce in the form of a QR code, which can fetch detailed information from the system. Similarly, the regulator's life becomes a great deal easier. They can track the journey of every seed coming into the country until the offtake. They can integrate with the hemp platform to automate submission and the granting of licenses and permits swiftly. Gives them a bird's eye view of the industry as a whole and the flexibility to drill down to a particular farm or storage location, which will narrow down the need for frequent inspections, thereby considerably reducing cost. They can evidence test reports, geotagged photos to simplify the compliance process. Regulators can receive push notifications on the mobile app on each submission, as well as notifications done by the farmers. They receive enterprise-grade security with the blockchain technology, ensuring tamper-proof data and transaction records crucial for compliance. Biometric-enabled access to the mobile app gives additional assurance of activity by a designated person only. By utilising digital transformation skills, together with a wealth of blockchain experience and knowledge, and further integration with existing technologies and institutions, NatSoft and HempGrow are pioneering solutions for the hemp industry that will have significant and long-lasting impact. We look forward to further discussion with interested parties, where we can provide a more detailed presentation on the HiTrack system. Contact details.
So as you have seen, this was one of the most comprehensive blockchain implementation we are doing, where we are using a host of technologies other than blockchain integrated with blockchain. So to enable a lot of functionality required by the farmers and the regulatory agencies who actually are regulating this crop. So as you have seen, we are tracking data from the sowing of seeds to harvesting of crop and all the activities in between, like the flowering, when the flowering is happening, whether what kind of fertilizer is being used, what kind of pesticides is used if required, and at every stage of this process, the regulator gets notification. And if he wants to conduct an inspection, he can come and conduct the inspection. There are some things which they were doing by conducting frequent inspections, but a lot of that inspection need is reduced by having all this data available on this platform for the regulator, so they can go and check any farm and any of the activities which are happening on the farm. And apart from this, we are also using IoT technology to capture the data pertaining to humidity, temperature, and soil moisture, which in the long run will help to improve the crop performance and also give analytics to the growers as to which seed is actually giving best crop in what climatic conditions or what kind of moisture level or what kind of irrigation. So over a period of time, this will become a solution which will solve many challenges which the farmers of hemp are facing currently, and it will make their lives much more easier from the compliance standpoint. So this was the first solution which we were showing, and I think Sai will continue a couple of other solutions from here.
Yeah. So now, yeah, thank you, Gopal. So hi guys. So now let's discuss about the university certifications. I hope you might have.
Sai, can I interrupt you for a moment?
Yes.
Yeah. Just going back to the last slide, it's also a perfect example. I don't know, I didn't hear Gopal talking about it, but just reiterating that agriculture trace, any agriculture, is not limited to the traceability itself, but you have a IoT on top of that to actually track the other parameters on the blockchain, and for the industry to say is what were the weather parameters, what were the soil humidity, and all that stuff. And you put AI on top of that to say is under what patterns, under what weather conditions you had the best yield of the crop. So just understand that blockchain gives you the basic foundation for doing a lot more things than what you were not able to do before. Okay, that's where wanted to re-emphasize that. Over
Yeah,
to you.
yeah. Thank you, Sham. So I hope you guys have got excited looking at the university certifications. So basically, so what is the purpose of getting the university certifications blockchained? So basically, before that, let me tell you a brief background on. So globally, there are like more than 25,000 universities with almost 250 million students graduating every year. So then why is it meant for, and why is it important to store the data digitally, that too in a tamper-proof way? Because a paper-based system is always subject to loss, even fraud. And with an increasingly mobile population of students and workers, a centralized database of credentials and achievements makes sense. Whether you are moving to another educational institution or a new job, or a new country, and for refugees who have no copy of their degrees. So for them, this kind of centralized database where someone can handle or someone can manage access the university certifications which they have physically, I mean the paper copy which they have lost, and also like some sort of secure online repository would be helpful. The solution is targeted at storing educational records on the blockchain in the most secure and tamper-proof way. Let's say like different departments can be onboarded as different nodes in a blockchain network. And also okay, before that, I would like to tell you the main advantages over this traditional paper certificate. One is storing an immutable certificates. Digital certificates in an immutable way which cannot be forged. When I say immutable, once the data entered into the blockchain system, it can never be altered or tampered. So let's say you might say like in the preliminary examination, I mean in the main examination, you might have scored some 80%, and you might have opted for a betterment, or you might have revisited the examination. Then you might have scored 81. Then you might think like, okay, then if I was not able to update the marks from 80 to 81, then what is the purpose? So technically there is no kind of alter or delete from a blockchain database, but there is always a provision of adding a new record in the ledger, so that whenever someone comes and tries to modify, I mean someone comes and try to get the information, okay, this guy has scored how many percentage, how much percentage in this particular semester, etc. Then by computing the ledger, it will compute and it will tell you like, okay, this guy has scored 81%. So technically you can still update your marks, you can still update your scores and all, etc. But the earlier record will always be there in the blockchain forever, so that in future, in case of auditing, if someone, let's say some kind of accreditators or validators want to validate or audit the transactions, audit the certificates, etc., then they can see, okay, initially this guy has scored 80, and later because of some improvement, going for an improvement examination and all, etc., he might have scored 81 and all, etc. And also like this particular certificate can be used forever in the life of this particular student. Let's say like in 2020 he has graduated, and in 2021 he might want to join a new job, and wherein he can simply give the hash, or he can simply give the access of this particular certificate in the blockchain system to his employer, so that employer can easily able to identify the certificate which is validated by the concerned university, and which is in a blockchain system which cannot be tampered, and this record will be forever. And this guy can use the same certificate for his next employer in maybe in 2025 or whatever. So for whatever the purpose, he can use the same certificate. And even for the for case of employers also, this might make sense, and this might make easy for them to identify the forged certificates and all. So let's say if you want to let's say if someone has tampered your certificate, then obviously the certificate stored in the blockchain will get the hash of the certificate stored in the blockchain will get mismatched with the original one. Then obviously that particular malicious certificate will be caught easily. And then certificates can be verified only by the authorized persons on the blockchain. Maybe like the issuer of the university can only validate or verify. The student can, the other students or the other department faculty cannot have access to verify, etc. And then time required to issue or reissue the certificate is significantly reduced. So I want to show you a quick demo, a muted one.
I think the volume is very low. So
I have muted the video, Sham.
So let's talk through.
Yeah. So basically, when you see here, the member or the student registration is happening. So student registration into the blockchain system will always be one time, and later on, the same registration or the same identity can be mapped for his higher education or higher studies and all. So now here the registration was successful. Now using the registered ID, he can upload his certificates. Okay, before that, let's get the details from the blockchain. So these are the details stored in the blockchain system against that particular student identity. Now this particular student can upload his certificates, which will later be validated by the concerned department from a university, and then the verified certificates he can be able to transfer it, or I mean he can be able to allow access for the other stakeholders like maybe employer, etc. So now he has uploaded the certificate, so he'll be getting a certificate hash. So now he is able to download the certificate and the same credentials. So once the certificate is verified, he can then allow access of that particular certificate to his employer or to his higher education institute. So let's say he has submitted his undergraduation certificates here, and then he want to go for an post graduation. He can simply use this kind of mechanism, or he can use his digital certificate identity for his post graduator to validate the authenticity, to validate the originality of the certificate he has issued. And this saves a lot of time for universities to issue the certificate and all, and it reduces the lot of effort universities and others put in order to identify the forged certificates and all. Let's go for one more. So business registration. So this particular use case, we have worked for an US government. So basically, the process of registering a new business, it usually takes couple of weeks, and also there are a lot of intermediaries, or there are a lot of agents involved in this process, and also the chances of getting from a compliance perspective, the chances of documents submitted can be forged are very high. So in order to avoid these kind of scenarios and all, we were trying to we can go for a blockchain based system, so where within which a state could be transformed by leveraging the advantages like platform brings citizens, registered agents, legal firms and government departments onto a single platform. All the different stakeholders will be on the same platform, wherein which they can share the data, and they can share their validity, they can share their approval mechanisms and all. It reduces lot of time, efficiency and also paperwork, and also like the communication gaps or the coordination between the different parties involved in the entire process will get reduced, and all of the other parties will be on the same page. And also it enhances the transparency, reliability and also security of the records. So as we have discussed earlier, like all the records stored in a blockchain are tamper proof, and also like once the record updated in the blockchain, it cannot be tampered. So that way it helps the government, it helps the compliant authority to verify or validate the document submitted by that particular person. Let's have a video. So generally the process of business registration takes different steps. So especially for one of the states for US, so it takes 6 steps. So first is the entity registration, and then structuring the entity, like so what kind of corporation, what kind of company it comes under, and then location, and then the taxation processes, and then the employee details, and then finally the licenses. So once all these are submitted, forms and recommendations of that, so all the forms, recommendations and the rules and regulations with respect to that particular registration can be accessed directly. So they can submit all the forms and recommendations based on the by tagging that to a particular SSN identity of that citizen. So on whom the company or the corporation they want to get registered. And now, okay, see, you can see the transaction hash appeared on the screen. So this particular transaction hash, this certificate hash is the unique identifier of that particular certificate. So when someone tries to tamper that certificate and resubmits it, always the hash will get changed. So I hope the computer science background guys may understand, like, so hash is something like, so for a fixed set of input, how many times you do the hash, always the output you get will always be the same if you use the same hashing mechanism. So if someone want to tamper the certificate, maybe they want to edit the date of birth, or they want to edit some kind of parameter, then the hash of that particular certificate will get tampered. I hope that case will also be covered. And now registration of that particular company with respect to different authorities or different departments in the government. First is EIN registration, so employee identification number, employer identification number. Now when they submit this particular record into the blockchain, so at the bottom you can see the transaction receipt. The EIN number we receive is 3, and you can see the transaction hash, the block number in which this particular transaction has hash, and the block hash. So you can get, you may get a doubt like what is the transaction hash and a block hash. So basically a block is like a block contains n number of transactions based on the consensus and based on the logic which we have kept while the blockchain platform was made up and running. So typically a block can have n number of transactions. It can be restricted to size of the block, or it can be restricted to size of the transaction. So each transaction in the system will have a transaction hash, and all the all the transactions within that particular block are grouped together, and also the sorry so all the transactions are grouped together to form a block hash, which also include the cumulative hash of the previous block. So that way we were linking all the blocks and forming it like a chain. So that is how we were building a blockchain. So let's say I can tell you an example, like if the transaction in this particular block is getting tampered, then obviously the hash of that particular transaction will get mismatched, and the block hash of that particular block will get mismatched, and also all the block hashes of the preceding blocks also will get mismatched, because the cumulative block hash of this particular block will be captured in the next block. So that this I can explain you bit detail when we go for a technical session. So now, so let's say, so you might get, you might have a doubt like, so what is fictitious name and what is EIN? So many of the companies operate in a fashion like a company will be having a trade name, and also they will have something like a fictitious name. So a common example I can say like, so Ola. So when you consider Ola, so Ola is a product and they are operating the cab services business on the name of Ola, but the company is getting registered as ANI Technologies, etc. So in a similar fashion, so you can submit a fictitious name with respect to that particular state for your entity. And also there is a provision of submitting and getting a local ordinances and then submitting from the health departments and all. One second. Yeah, so health department and then fire department. So all the different stakeholders or the different departments involved in this particular business registration and licensing are getting onboarded to this particular system, and that particular department can issue a license. So while issuing that particular license, so they have to log into the system using their private keys, and then the SSN of that particular applicant to whom they want to issue, and then the EIN which have already been registered or issued. So when they click on generate, a certificate will be generated, a blockchain certificate. So you can see the certificate here, and the generated certificate can be uploaded once the sanity checks and all etc. were happened. Once it is getting approved by all the parties, yeah. So here you can see the certificate hash once it is uploaded to the blockchain system, and using that particular hash you can verify or download the certificate. So let's say if you want to give the access of your particular document or of your particular license to some third party, when you want to go for a loan or etc. So how do the other party trust, or how do the other party rely on the authenticity of the certificate which you have submitted? So there might be the chances of submitting the license or submitting the record has to be verified, right? So the chances of getting it forged are there. So for them, it is an extra burden, or it is an extra step they have to validate it, they might have to approach it to the original issuer, or they might go to some third-party verifiers, etc., taking their risk, and they will validate it. But when they have a access to some system like this kind of a blockchain system, so they can directly log into the system, or they can access to the system publicly depending on the need. They can simply put the license hash they have received, and they can click on download. They will be able to download the certificate, and they can able to see the certificate issued. So this is how we can make this particular certificate transparent, that too only to limited people. And while issuing this certificate, maybe like while providing this certificate visible to the other party, we can provide an option like, okay, this particular license or this particular hash is visible to that guy only for n number of minutes. Maybe like, let's say like the banker want to verify or validate your certificate, then you can log into your system and you can allow banker to access this system for maybe for next 1 day, 24 hours. You can put that check, and the banker can be able to verify only within that period time. So as and when required, he can't be able to come. So if they want to verify, so they can approach you and you can give the access, maybe you or the authority who has issued it. Okay.
Sai,
So
just to add, this is where the whole architecture and the way the blockchain is going to be implemented comes into being. We spoke about the types of blockchain, public, private, permission, and all that stuff. Here is again a use case where, depending on where you are implementing and for whom you are implementing, you actually create an appropriate architecture. Sometimes you even create a hybrid blockchain where you will have a public blockchain for the government, and you can have a private blockchain for a set of enterprises to work and then access some limited data from the public blockchain. But then they do rest of the things on their private blockchain. So there are combinations like this which are coming very quickly, and this is where Vidy mentioned about our research on interoperability. Right today we are extensively exploring what are the things we could do on interoperability. Yep, connecting back with whatever we have spoken. Yep, thank you.
And one more. So like a unicoin, I can alias it as university coin or a university token. So why a university need a token or a kind of cryptographic material to be used within the campus and all, etc. So there can be a number of questions. So one is like, as Sham has mentioned earlier, so the payments. So all the payments within the campus can be made using campus token, some kind of a campus token. And also we can use it for the purpose of like a rewards and redemption mechanism. So based on the activities, so based on the performance of the students and all, his particular mentor or a tutor can provide him, can transfer him a few number of coins as a recognition, and that particular coin he can be the student can be able to redeem it for some particular purposes, etc. So like basically like again I would like to tell you like, so unicoin is a digital utility token which is used as a medium of exchange within the campus. So I mean for different purposes like ranging from tuition fees, cafeteria bills, examination fees, and some other laboratory fees, departmental fees, and all, etc. And the transactions are very fast if we go for a kind of a private blockchains and all. If we go for a kind of a public blockchains and all, these kind of transactions are still fast when compared to kind of a cross-border transactions. Let's say if there are some overseas students studying in that particular campus, so paying fees for an overseas student in a fiat may be like a 2-step or 3-step process. So if they have access or if they have visibility to this particular kind of a crypto environment, they can do these transactions as fast as light. And then fraudulent chances, fraudulent activity. So all the fraudulent activity happening across these kind of environments can be brought and can be answered using these kind of blockchain systems instantly. So I'll show you a few slides. So they can be able to log into this particular system, and you can see, so this particular application is built on top of Ethereum. So you can see the Ethereum address or the public key wallet address of that particular ID, and then the ether balance of that particular ID, and the token balance, Unicoin token balance. So here we have an option. So here we are providing an option for that particular candidate to transfer these tokens to his peers, his friends, his students, and all, etc., and also pay his utility bills, maybe mess bill, campus fee, etc. You can also see the previous blocks and the previous transaction history, and the number of tokens he has transferred earlier. So you can see, like, for what purpose he want to transfer these tokens. Is it for like a residential hostel purpose, or is it for a cafeteria, or is it for a tuition fee and all, a particular course fee? So you can observe, like, so when they select this particular option, and when they click on the number of tokens to be transferred, they can easily transfer to the wallet address associated with to that particular entity, maybe that as hostel department or cafeteria and all. And they have the access to use these tokens for some other purpose for their internal transfers and all. So you can see a live transaction now, transferred successfully. You can see the transaction appeared here. So block number 4689561. So this 2000 tokens transaction is which we have done now. You can see the transaction receipt here in the ether scan. So basically this particular application is on a test network, Ethereum test network. So Ethereum has few test networks called Ropsten and all. So Ethereum, this particular application is deployed, this contract is deployed on Ropsten test network. So you can see the Ropsten above the ether scan here. So this is the particular transaction which we have done. So the transaction hash we have received when we access this particular transaction, we have got one block confirmation, and it is 1 minute ago. The from wallet, this is the wallet address from which the transaction has happened, and this is the contract address. Contract is like the smart contract address where this particular transaction has been executed, and the number of tokens transferred from this wallet, from wallet to wallet, 2000 ERC20. So ERC20 is an Ethereum tokenization standard. So there are few other standards as well, ERC721 and all. So that can be chosen at the time of designing this particular this particular application. And the value of this is ether. So this particular token don't have any monetary value, and the gas limit. So you can say, you can get a doubt like what is a gas and all. So basically gas is the fuel engine for this Ethereum blockchain. So gas is generally measured in WEI. V is the simplest units of the ether. GY is the next simpler unit of the ether. So basically 1 GY is equal to 10 to the power of minus 18 of an ether. So gas limit is the total gas to be consumed for that particular block, and then gas used by transaction is gas consumed for this particular transaction, and gas price. So gas price is like gas transaction into some 10 power minus 18 and all. So there is a standard formula for that, and the actual transaction fees in terms of ether they have mentioned, and nonce. So basically what is nonce? Nonce, you will heard about the word nonce in mostly public blockchain. So nonce is generally used to find or used to solve a particular block, used to mine a particular block in order to receive or achieve the consensus or the cryptographic puzzle which has pre-built at the time of consensus. So that we can cover when we discuss more in public blockchain in later sessions. So this is how typically an Ethereum transaction looks like. So now, so using this particular option, you can transfer the tokens to one of your friends, maybe your peers and all. And that transaction you can see from their wallet. You can, I think you will be able to see this particular transaction 4889 4689 564 150 tokens which we have done now. And the transaction received for that particular transaction 150 tokens. So 1 second. Yeah. Okay. So now let's see the token from address. So we are going to that particular student account. So you can see the previous transaction. So all the transactions made in Ethereum blockchain are public and visible, accessible by everyone in the network. So that is why we are able to see the transaction of this particular account holder. In fact, the previous transaction which we have done for some utility. And this is the transaction to which this guy has sent the 150 units. Yeah. So basically, like students can get to learn about blockchain by using these kind of applications or prototypes. So they'll be able to know what is the mining. So how a typically like how a transaction is getting mined and a block is getting created, accepted in that particular network and all, in that particular public blockchain. So yeah. So
you literally have watched the use cases where we can do better engagement with students. We can have academic certifications on the blockchain. We can actually do every transaction at a university through a blockchain, including transfer of coins between students. So there is an automatic adoption of blockchain in a campus. So if any university pursuing things on blockchain, want to do more on blockchain, should have basically some of these solutions so that students can use and actually experience the advantages of this.
Yeah. So, I think we can go for a Q&A.
So I think there are some 14-15 more solutions which we could have shown, but we consolidated them to just for this session. Didn't want to overload a lot of information with all of you, but hopefully that will give you a good view what theoretically we have spoken, what theoretically you have heard about blockchain, and how we are going towards the implementations. So now we will take on questions, and I think some questions are already there on the chat screen. Some responses have been given. Vidy, are you going to come back and let's do a Q&A? Any one of you have Q&A questions, please ask now. And then any old questions, if we are pending, then we will respond also. Vidy, I think we should start off with that energy grid and what we are doing on the energy grid area.
Okay, let me just scroll to find the question.
Can you throw some light? Yep.
Okay, so you guys can see the question up here. Can you throw some light on your research on blockchain applications in smart area? Okay. I have done a fair bit of work in smart grid itself. I had a couple of PhD students who have graduated, who have done research on smart grid without blockchain, because in those days, this was 2011, 2012, blockchain was not mainstream. So we have done work in smart grid during those times, and what we have built is a system where energy sharing can be enabled between different prosumers. So prosumers are those who can generate electricity as well as sell electricity. So we built a complete framework, a prosumer community management framework, where we built different solutions for selecting who the prosumers are, what is their capability. We built a ranking mechanism to rank the prosumers on different levels for different levels, like similar to the frequent flyer points we get for airlines. So we have bronze, silver, gold kind of categories. So we adopted a similar idea in smart grids as well, where we categorized the prosumers into these kind of categories. We also worked on building a solution for collectively generating electricity and sharing it with the grid or with the participants in the smart grid. So all these things we did. We did not implement this in blockchain, but this can be easily incorporated and built using a blockchain. Blockchain makes it much more possible. I mean, the blockchain technology will be very much suited for doing such an implementation in the real world scenario. So that is what we did in the past. I am going to get one new PhD student who is coming to join us from IIT Kharagpur. And we are going to work with him on some new areas in smart grid and blockchain. So Natsoft, Sham, and his team, and everyone at the Blockchain Lab would be actively involved in driving this area of research going into the future. Sham or anyone else, you want to guys comment anything?
I had something to also add on to Vidy. What you have said is we also know that the energy market is not completely deregulated in all the countries. So you have restrictions on what you can actually do. And we are talking about prosumer and all that only in Australia, and perhaps we can't do that in India or some other markets. So what we have is, on one side we have the research capabilities with Vidy himself actively participating, his students participating in doing the research on the grids. We have another platform which is called Envision platform, which actually gives the big data, IoT, and through the edge connectivity with all the devices, with all the traditional and renewable sources, and bring it onto a platform with AI on top of that for optimization in many ways. So you can have weather prediction, you can say how much of generation will happen, how much of consumption will happen based on the weather patterns. You can do smart buildings, smart townships, smart complexes, and smart plants with the kind of research and development work which we are doing today. Okay. Thanks, and let's step on to the next one.
Next question was from. Okay, so next question was from Ramesh Reddy. Bitcoin fraud, how is it addressed with respect to traceability? So Sai, do you want to take that question, because I saw you had responded to it?
Yeah. So basically, like there are different frauds happening across the usage of Bitcoin. So basically, like if you are trying to make your private key access, so if you are trying to give your private key somewhere, like if you are using your wallet in an exchange to trade or transact your Bitcoin, it is like you are giving the ownership of your Bitcoin private key to them. So when that particular exchange or when that particular system is compromised, so obviously you will be getting you will be getting lost of your particular Bitcoin. So generally that is the reason why people prefer using the decentralized exchanges, wherein which they won't allow or they won't handle your credentials with themselves. And also, like as you know, like the identity or the identity sorry, the identity of that particular of a token holder of a wallet holder is not linked or not mapped with to the real world entity. So let's say like you want to transact a Bitcoin to some XYZ public address, and by mistake if you have transferred that to XYZ1, so then it is like 100% you have completely lost your Bitcoin. Unless you know that a particular receiver in the real world, you can go them and ask them to roll back it in the real environment. So so what I would like to say is like, so we need to be very careful in transferring or in dealing with real crypto entities. It may be Bitcoin or Ethereum, etc. We have to be very clear, and once a token is transferred, is always transferred.
Okay, thank you very much. Thank you, Sai, for addressing that. The next question is also from Ramesh Reddy, ownership and storage of data. So I'm not really sure what the question is here, but I believe it may be, the question may be that who owns the data on the blockchain and where the data is stored. Probably that is what you want to ask. So anyone want to take this question?
Yeah. So basically, like coming to coming to the ownership, it is like it depends on the type of the system and type of the application you want to do. Let's say in case of a supply chain kind of a mechanism, so the ownership of data of that particular actor will always be there with them, and the data maybe an attribute based data, so will only be accessed or allowed by the other stakeholders in the environment to have it. So still the ownership will always be with the same stakeholder. In case if you go for a public blockchain, the ownership will be there with you only, but the complete data will always be visible to everyone in the ecosystem. So that is why generally people prefer for a hybrid kind of an application wherein which they use or they store that particular type of transactions, record that particular transactions in a private network, private blockchain network, wherein which only the actors in that particular channel will be given access, and they don't end up losing their particular data. So even it is private or public, the ownership will always be there with the same stakeholder. Coming to that question, yeah.
Sai, Ramesh has also keyed in some comments saying that banks can retrieve fraud money. So basically, this gives the complete traceability. And Ramesh, you're right to say that this will lead to basically, as I said, anti-money laundering and fraudulent money storage and all that. So this will put an end to perhaps those, right? Okay, let's move on.
Next question is, what do we do with historic data in case of transferring from existing database to blockchain? So yeah, so if you have historical data in an existing system, we can build an integration of that system to the blockchain system, and the historical data can also be transferred to the new system. And once it is on blockchain, it cannot be tampered with from that moment, because once it comes to blockchain, it is not reversible.
So
The other thing is for what purpose, right? So we typically may not be able to bring historical data if there are no transactions happening on the blockchain, right? But we can combine our data of blockchain with any historical data to do any analytics part of it. But you can't make historical data come on a blockchain and show traceability. Am I right?
Yeah. Yes.
Okay.
I'd like to add to that, Sham, because I responded to that query in a different way. So what I suggested was what is possible is you could come up with a data or the existing information transmission scheme on how you are going to get the existing data on the blockchain. So one thing that we would need if we want to transfer an existing set of data to a blockchain network is some way of doing validation or verification or consensus on this on the past information that is recorded. So we cannot go. We would not be able to go back and change. Put this information at a particular date when that transaction had happened, but we could add it on today's date, but provide a reference to a previous date in when that transaction actually happened, and we could we would have to find a creative way in which how we can get consensus around that information. So it is possible, and it will be something that companies would have a question in mind to move their existing data to blockchain. So we should. I think it is a very interesting research question as well of how this could be handled, and a very practical problem as well from leading to adoption. Because I think I saw some other questions from someone in the chat box which was about adoption. So this could be one way as well to boost adoption.
Thank you, Vidy. So the next question is, throw some light of case study with respect to integration of blockchain with ML and AI.
Okay, Sham.
This has got a linkage with another question from Shailaja, which said is, can you tell us how AI is working with blockchain in energy management? So I had earlier shared about agriculture and crop and yield, and where I have said is basically you can link the yield of a crop or the quality of a crop with 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 the weather and seed, fertilizer, and other ambience condition, including water, irrigation, water quality, etc. And you can even have image analytics on top of that. So for example, if you're talking about palm plantation, palm fruit, when it is plucked at a particular time, depending on the color of the fruit, you can get the best yield of palm oil and with the levels of acidity controlled. So if you take it after it matures, it has more acidity levels, and the usage of palm oil or the yield will not be as much. So you do image analytics with the other patterns, what we have, soil, humidity, and all that, to gauge what is the right way in which palm should be produced and maintained and plucked. So you get all the three using AI. This is where you have AI and machine learning coming very much. In energy management, I did speak about the building management, right? When you have utility optimization or energy optimization in a building, or a complex, you exactly get to see the consumption pattern. You exactly get to see how the usage is, and then where you have avenues to optimize. How do you gauge that? Now, based on outside weather condition, there are tropical countries where the weather pattern changes even during the day. So you can have different controls based on the weather during the day itself. Then how do you control the chiller plant and the HVAC system, right? The whole HVAC, the system nearly consumes 60% of the energy of a building. 60% is coming from there. So if you can better control the HVAC system, the air handling units, and compare that with the ambience and with the number of people who are in the building at any point of time, and in that particular floor, in that particular room. And if you can do a comfort level analysis on all this, there's the AI which we can do on this. There is another AI which is in a deregulated market, which which is about you have a specific generation capacity, you have a specific storage capacity, and then you will say is I can generate say 20 kilowatt of say 100 kilowatt of solar. I can do another 100 kilowatt of wind today, but based on the weather pattern, it looks like it's going to be much more cloudy over the next few days. So I will do more wind but lower solar. So these are the weather. With the weather forecast, the AI can actually say how much of generation will likely happen, looking at the historical patterns and looking at the weather conditions. That will also tell you that how much of power you actually need and how much of power you actually need to buy. So once you get that, you can then do one level of optimization. If you have storage, then you can do a next level of optimization and AI to say that now I want to consume power in the peak period from storage, and then I will use the I'll buy power in the night time and then store it to the battery. So battery will store at off peak times and then actually consume in the peak time. So you are reducing your power consumption multiple times, and those are the AIs which are possible, and they are actually in implementations today. So why blockchain? Blockchain will again give you some traceability of the energy production, because a lot of people, when you are supplying back this information to the grids and they are state-owned companies, then you need a record of how much you have actually done and a confirmation and validation from the regulator himself, so that you are clear that this one has been generated and this much of bill and payments you need to know. You know the situation here in India about the outstanding payments on the on the discourse and the gencos. So this is why blockchain will help you in doing this. And when there are prosumers, you can actually do peer-to-peer trading. You can generate, you can buy, you can sell. Hope that answers. Yeah.
Yeah.
Okay. Next.
Next, I have a question here. We sold a property back ago on notary basis. Can we make digital authentication of that property through blockchain? Can you explain me that?
At this point of time, you can't do unless the regulator himself or the government himself has initiated to put this whole thing, the ecosystem, on a blockchain. So if the blockchain has the capability to bring all the transactions, then at a point of time, the old records plus the current title records, everything can be put on the blockchain so that the new transactions could be addressed on blockchain. I don't know which state and what is the current criteria, whether they have already been put on blockchain or not.
Yeah, there is a question asking from Raghavendra. In some cases, if I forgot my credentials, can I retrieve? So obviously no. Once a private key is lost, then the access to your particular wallet or particular application is completely lost. You cannot retrieve it. You will not be able to retrieve that. So you have to be make sure to save your private keys as much as possible.
Any other questions?
There were some more questions, Gopal. Do you want to pick them or shall I? Because I answered quite a few of them. But
Yeah,
we
I
can.
was just looking at, so a lot of questions seems to be answered on chat. So I'm just going through if there is something which was not answered.
I think I have also scrolled through. I think more
Can blockchain interface between two ERP systems?
Blockchain does interface with the ERP systems automatically. So, yeah, I
Okay,
respond to this. Yeah.
I think Sham also responded to this question. I have also replied, but basically,
Yeah.
to reiterate the response, handling of mergers and acquisitions. One of the important things in mergers or acquisition is the uh, trust between the two parties who are transacting. Do they, so if so imagine a buyer and a seller, right? So one person is selling a company, other one is acquiring, or two companies are merging. There would be situations where you have to assess the stock distribution, stock pricing, when these mergers happen. So from a financial point of view, when companies are doing due diligence for acquisitions, they would want to know whether the information that they have been provided during the due diligence phase, is it reliable or not. And in that case, and or in that phase, blockchain based data proves to be very valuable, because you can have the history of this information on the blockchain. You cannot just fabricate content or information just to make the company profile or company stats look better, just because you are in the market to sell your business. So having that regular information added to a blockchain builds up that credibility when it comes to selling a business or during mergers and acquisitions.
And Vidy, if you remember in the last conference we had on oil and gas, uh, DigitalX was doing a project with EY on exactly this point on how JVs can be handled. In the oil and gas industry, there are very, very complex scenarios on joint ventures, basically, and regulators. So uh, there are costs going in, there is revenue coming in, there are losses and profits which need to be shared. So all these things were being put on a blockchain to say is for a period of time how the cost, profits, and everything will be shared in a joint venture, because somebody will own the well, somebody will be responsible for exploration, somebody will be responsible for downstream, upstream, the downstream activities and all that. So there is a good case of putting all these maps from ownership all the way to downstream, how these things work.
Yeah, that's right.
And there was one here which says, can student grade submission and grade sheets distribution can happen on blockchain? I think that's a good question, because we are already working on a POC which allows students to be rewarded for desirable outcomes achieved by them, whether it is submission of assignments in time, whether it is attending classes regularly, or whether participating in events where they are scoring well, whether it is a quiz show or whatever. So you have all the information pertaining to their performance on blockchain, and the faculty will be able to reward them with a university coin, which Sai has explained. So they can get coins for desirable behavior, and they can redeem those coins with some sort of gifts or benefits within the campus. Yes, that is possible.
Yeah. Mr. Shiva Sharma, yeah. Can we, NITW, collaborate with you on, yeah, you have the Blockchain Innovation Center. We have the blockchain technology. We have the solution. Actually, you have seen most of it today. This is a good starting point for you to start and have the learning management as an added module to that. But bulk of the certification portion is already handled in the platform.
Okay. There's one very interesting question here by Ashok. Can we expect an alternative to internet itself in the near future? I think it's a very interesting question that you posed, Ashok. I mean, we are currently so much reliant on the internet. If an alternative to the internet has to come, it would have to be very. I mean, what were you thinking in terms of an alternative to internet? What is it something that is currently missing that you're thinking of that could be added to it? Shyam, you seemed frozen on the screen. Gopal, are you there? I think we do have some connectivity problem, I guess. Okay, Sai, can you hear me?
Yes, Vidy. Yeah.
Okay, so I think we two can take the session ahead. There seems to be a loss from the other two. Okay, any other question that we had here? So Raghavendra asked, name the two types of records that are present in the blockchain database. And Sai, I think you replied to that
Yes.
question, and the response was, yeah, you can imagine two things at least: transactional records and block records that are being added to the network, to the blockchain. Any other questions from the audience right now? If you have, please do post them. We can take them up. Okay, there's another question here from Raghavendra. How is blockchain ledger different from an ordinary one? I think Raghavendra, we did answer that early on in the session, or where I presented, where I talked about how blockchain is different compared to a traditional database. So relational database versus a blockchain database discussion we did early on. And one of the main difference in these two scenarios is that a blockchain ledger is immutable. So you can add information to the blockchain similar to any other relational database, but you cannot delete the information. So I think that answers it. Sai, do you want to add something to that?
Yeah, basically, like all the transactions in a blockchain environment are cumulated together. Basically, a kind of what I can say, a concept of linked list can be put in here. So wherein which in linked list you can go and add a set of data in between the two transactions. But here in blockchain, that you cannot do. Each and every block is appended together. So let's say like nth block will have the information of all the transactions, like the cumulative hash till the n-1th block, and also the transaction with respect to nth block. So in order, if you want to make a transaction change or a transaction update in some n-2th block, so then you have to make the changes with respect to n-1, n, and all, etc. So using this, I mean, changing all these will require a lot of computational energy and all. So obviously, while they were doing it, the background jobs will identify that the data has been tampered and all, etc. So that way we can easily able to identify the frauds, basically like the data tampering happening with respect, maybe because of the malicious administrators and all. So wherein which here in blockchain, so whatever the data you are trying to add, whatever the data you are going to record, it will always be added at the last of the ledger, always added at the latest ledger. So always the data is append only. Yeah. Vidy, I think we can look for something else. So I think Raghavendra these answers to your question.
So there's a question from Sudha, and she is asking, are we going to cover anything about Hyperledger Fabric in this session? So to answer that, I think, Sudha, this is not a technical session that we have arranged today. Hyperledger Fabric has been something that we have worked very closely, and some of the solutions that we showcased today were built on using Hyperledger Fabric. So we would definitely, given the interest on this, we can definitely run another session only focused on Fabric. Shyam or Sai, do you want to add something to that?
Yeah, I think
Shyam, you're on.
So
You're on mute, Shyam.
we can have a detailed session for Hyperledger Fabric. So there are tons of things we need to discuss when we go for a Fabric. So,
including building up of applications, basically,
yes.
right? So we can do Hyperledger, we can do Ethereum, we can do other platforms, basically. Yeah. Raghavendra has another question regarding double spending.
Yeah, basically blockchain solves the problem of double spending. So basically, a common example of double spending I can say is like, so most of the pending cases in Indian courts were related to property transaction, illegal property trade. So a single property is trying to, some malicious actors are trying to sell a single property to multiple people. So wherein which, in case of a blockchain system, you will always be able to identify the latest owner. So what all the path it which that particular property has traveled and all, etc. So whenever you are trying to do a transaction in a blockchain, so if you are trying to spend a transaction which is already spent, then the other nodes in the blockchain system will identify that, and they will send they won't accept the transaction in that particular blockchain, and obviously and never and ever that transaction will not be getting mined. So the chances of getting this transaction duplicated and added to the block will never happen. So this is how a double spending problem can be solved using blockchain system.
Are there any other questions from the audience?
I think Vidy, we can still take questions, email and feedbacks, and we can we can do follow-up sessions. What we are planning to do now is, because the faculty has been involved in this, and we want the faculty to now go and speak and encourage the students to join. We might be doing a revised session. That will be a multi-day session, which will involve from introduction of blockchain all the way to construction of a blockchain, including work on either Ethereum or Hyperledger. We'll choose one of them, and that should be done in the coming 1 or 2 months. We will let people know when is the next session being planned and how we go about it. Okay. Vidy, can you also mention about the other webinars you are doing? Because we don't need to do exclusively for this one. We can actually use your webinars also, which you do slightly independently, and invite these people to join in, right?
Yeah, so for those who are listening, I do some webinars regularly, once a week or so, on interesting topics that are related to students. For example, tonight I'm going to run a session, a webinar on managing mental health for students. So I invite all of you, if you are not so tired already by listening 4 hours today, to please join. I'll be there. It normally runs for 1.5 hour session. And today, I'll just quickly show you. Give me one sec. So this is the session that I'm going to run later today from 2 o'clock Indian time. So I think from a student's perspective, I think managing their mental health is very important, ensuring that they have their best and the brightest mind doing innovative and interesting things rather than bogged down by mental health challenges. So today I have got two experts, Dr. Sai Lavekar, who is a counseling psychologist and a homeopath, and Dr. Preeti Kulkarni, who has an MA in Yoga Shastra and is an Ayurvedic doctor as well. So both of them are going to share their insights, their suggestions on managing your mental health and how you can be successful. It will be live on YouTube on my channel, same channel. So if you have not subscribed to the channel, please do so now. So you will not only be informed about this one, but you can also see any other sessions that we do. So please subscribe. I'll also share a link to this webinar so you can register yourself so we would know what is your background. And if you have any questions for the panelists, please do share that as well. And other than that, I do several videos on blockchain itself. So there was one question in the chat today, which was about education and students related things on blockchain. So I have done a 6-part series on blockchain and human resource management. So I suggest you can have a look at that. It talks a lot about, it gives a background introduction to blockchain, what is blockchain, and how students can get on a blockchain and through their studies and also progress further during their career. So having a record of all your school, university activities recorded on the blockchain is a good way to present your capability to potential employers. So like that, there are many other interesting videos on my channel. So I suggest you to have a look at it. It will be definitely an enjoyable for you. And if you're keen on learning blockchain, I think you'll find very interesting resources there. Okay. So yeah, that's all. I'll link for you guys if you want to register for tonight's seminar.
Yeah, Vidy, I think with all this, we can close today's webinar with a vote of thanks to all of you for doing good presentation, for the audience and participants who have patiently heard us and giving us questions and responding with very good motivational messages in between. And to CSRK Prasad Garu and NB Ramana Rao Garu for basically sponsoring the event and making this happen. So thank you everyone, and wish you good day, good weekend, and catch up with you guys in the next webinar.
Yeah, thank you.
Thank you. Cheers.
Thank you all. It was a great experience to share all our knowledge and insights with you. I hope you have learned a lot from whatever we shared today. It was an interesting journey for me as well, and for I guess for all others as well. So thank you very much, and I'll see you in the next webinar or tonight later if you join my webinar. Thanks, guys. Bye-bye.
Bye.